50% of my battery is still on. So I plead with you. This is not only applicable to this course, but any other course that you are doing. Make sure you have enough battery for the next class. If not, sometimes the lecture will go through, but at the end of the day, you will go through the stress of having to learn it on your own. Hmm? So I beg you, do your best, and then so that the best that the lecturer is doing, he can some fruits can come out of it. So last week we dealt with the hypothesis. The last 2 weeks we dealt with the hypothesis testing, and they just ended last week. We also went through the chi-square test, right? To be able to go through chi-square and see how best we can use the chi-square to test hypothesis. Uh, some of the few things we look at was that we actually spoke about the fact that with the chi-square, you are interested in how the you want to test whether there is a significant association between two categorical variables, right? But if the categories are more than and less than two, which means that if they are continuous in nature, then you cannot necessarily use the chi-square test to be able to test that. That way, you may want to resort to the z-test or the t-test, depending on if what the sample size is more than 30 or less than 30, right? I think we also went through some few examples, right? And one of them, just to rehash on, on some of the things, is the fact that solving questions or trying to understand how the chi-square work and how to calculate the test statistics is not difficult. The only tricky aspect of this whole thing is how do you get your expected value? If you're able to get your expected value and you employ this formula, it becomes easier, right? And remember, I did something like that, and I even made sure that I put this in a tabular form for you. For example, let me see if I can just write that again. So, for example, right? So, for example, let me use this whiteboard and see screen, white screen. So you see that the oh, my this thing is gone again. So let me just see how best I can use the whiteboard. So you see, oh, what's happening? But still, I hope you are not going to worry me today. Yes, I see what I'm looking for. Uh-huh. So this is the chi-square, right? Sigma, right? And I think when we had something like this, I made it known to you that when I have something like that, all I have to do is to make sure my O is written here and I have a nice column, right? So that I can have a nice column and have everything. I will just estimate the E. Then I have another column. I have O minus what? E. Then I have another column. Then I have what? O minus what? E squared. Is that not it? Then I have the last column, which is what? O minus E squared, all divided by what? E. Once I have all these column 1, 2, 3, 4, 5 columns, the summation of this one becomes the answer, the chi-square value that I'm looking for, right? The summation of all what I will get here will give me this figure over here. So it become very what pretty sure easier how to be able to go about this kind of question. I think I also left with you some examples, right? I left with you some examples. I think we solved this question, right? Have you solved the analog question? Have you? That's the watch preference question. Have we? I'm asking a question. It's not a rhetorical question. Have you solved this? Course rep. It looks like I'm talking to myself. So course rep. My people, can you hear me?
Yes, you can hear
Yes,
you.
sir, we can hear you.
And you will not mind me and I'm speaking alone. Eh? You will not mind me.
Sorry, we're trying to respond. The network sometimes keep breaking.
I know that if I had asked that you should mention your account number for me, you wouldn't tell me that the network is breaking. And especially our ladies, they would have given it to me without even, hey, they would have even type it. Hmm? Maybe next time that's what I will do. That I want your Momo numbers.
Okay.
And I know nobody will tell me that his network is worrying him. So I'm just trying to see so that if we can resolve this one for you to get a sense of idea. Now remember what I did, and I told you that to be able to get the chi-square out of this, I would want the simplified version of this. So you know that you have to get the total here, right? You have to get the total for here, the total here,
Yes.
right? So the total here will be what? 100. Total here will be what? 80. Total here will be 20.
20,
Total here will be what? 60. Total here will be what?
140,
140. And the
140.
total here will be what?
200.
200. So I told you that this is exactly what we needed to be able to what? To calculate the expected value. So if I want to go through what I did before, I'll tell you that we should have what 5 columns, right? Where your observed values are there. And what are the observed values in this case?
90,
What are the observed values?
90.
90, 40, and 10,
Yes.
right?
Yes, though.
90, 40, 10. What is the next one? 10, 40,
40.
10. 10, 40, 10. Have you seen that?
Yes.
Now, the next thing is that what is the expected value of this 90?
It's 100 times 140 over 200.
Perfect. Is anybody in this class that do not or cannot calculate this expected value? That would be giving us what? Hey, what's happening? Uh-huh. Expected value. So it will be what? It will be that 100 times 140 divided by what?
200.
100 times what? 140 divided by what?
200.
200. That will give me the what? The expected value of 90.
Yes.
Please, do you get that?
Yes.
What about this 40 here?
80 times 140 over 200.
Over 200.
80 by 140 divided by what? 200.
200.
You put the value there, you get the final answer,
Yes.
right? Remember, you put the final answer there.
Yes.
Then you do it for the next one. This 10 will be what?
20 times 1.
20 by what?
20
140
by
divided by
140
200.
divided by 200.
So you do each of these ones like that. Then when you come to this 10 also, it will be 100 by what?
60.
60
But
divided by 200.
yes.
If you come to this 40 over here, it will be 80 by 60 divided by 200. Then the last one will be over here will be what? Wait, nobody should mention the answer. I'm coming. Let me ask somebody here to be able to help me with that one. Who just entered the class? Eric, can you tell me how we can get the expected value of this 10? The observed value of 10. Eric, tell me the expected value of this 10. This 10. The expected value of this 10.
Doc, okay, thank you for the opportunity. I remember you gave us the formula.
So I asked a simple question. I'm not asking if I have given you the formula. I say give me the expected value of this 10. What is the expected
The
value
one
of
you
this
shown it.
10?
Oh, okay. Doc, in fact, I have forgotten it.
Okay. That's a sign of good
That is
student. That
honest
means
truth.
it's not about saying the honest truth. You are just in this class right now. We just went through for Steve, Simon. We just went through how we calculated the expected value of 90, 40, 10, and the rest. Just do this one for me, and you are telling me that you are forgotten because you are not following. It's as simple as that.
Sir,
Baga, what is the expected value of this 10 that I have
20
highlighted in
times
green?
60 over 200.
That's okay. So, Eric, have you seen? This is what we are doing just less than 10, 15 seconds ago. You are telling me that you are forgotten. It's because you are not listening. You are not paying attention. You are doing your own thing at the background. Now, once you have been able to do that, you will see that you put the figures over here. Then the next thing to do is to what? Subtract each of these is that is the expected value from the observed one.
Yes.
Please, do you get that? You subtract each of those figures totals you get from the observed values. Once you get that, you draw another line and say E minus the O squared. You take the square of the results, right? Then after you've taken the square of the results, that result is now going to be what? Divided by what? E. Please, have you seen that? You divide it by E, and that's all. Once you have done that, that is all. Then you now sum everything over here. Everything you see over here, you sum them up, and that gives you the chi-square value. That gives you the chi-square value. Please take note of this. Something like this, you shouldn't avoid it, and you can't dodge it in class. Now, there's another tricky one which I have given you, but I have not given you or show you the trick of solving something like this. Let's read this question together. A developmental psychologist would like to determine whether infants display any color preferences. A stimulus consisting of 4 colors, patches, red, green, blue, yellow, is projected onto the ceiling above a crib. Infants are placed in the crib one at a time, and the psychologists record how much time each infant spends looking at each of the colors. The color that receives the most attention during a 100-second test during the 100-second test period is identified as the preferred color for that infant. The preferred color for a sample of 60 infants are shown in the table below. They are shown in the table below. So you can see from the word go, How many are they? They are 4 colors, right? They are
Yes.
4 colors. And then it
Yes.
means that if on an average, each child is supposed to spend equal amount of time watching it, you realize that it would have been what? Each of them would have spent at least 15 on each of them, right?
Yes.
So the expectation in that case would be that this one, there will be a uniform expectation.
Yeah.
So that uniform expected value will now be, let me see whether I have the space here too. So the uniform expectation will be what?
60.
We have the O here. So the O, you have 20, right? We have 12, we have 18, right? And we have what? 10.
10.
So the E will now be what? 15, 15, 15,
15.
15. So our E, O minus E, over here will be 5
Yeah.
minus 3,
3.
3.
3, and
Minus.
minus 5.
Yes.
So you can see the next one will be what?
Square.
O minus what? E
Or square.
squared.
Yes.
Is that not it?
Yes.
When we square the 25, 5, it will be what? 25.
9.
When we square this, it will be 9. When we square this, it will be what?
9.
Another 9. When we square this, it will be what? 25. Now, the next of the formula will say that O minus what? E
All divided E.
square divided by what?
E.
E. Is that not it?
Yes.
So if you divide 25 by 15, it will give us what?
1.66.
1.66.
Yes.
667. Eh?
Okay, we can make it
If you divide 9 by 15, what do you get?
15.
9 by 15.
0.6.
0.6. Is it 67? Is it 0.67?
No, 0.6.
Just 0.6. Okay.
Yes.
Then the
Only
last one.
0.6.
Yeah, 0.6.
Okay, just 0.6. Eh?
Yes,
Okay.
please.
Yes.
But the first one is 1.667, eh? Or it's just 1.6.
1.66.
Is the first one 1.667?
367.
Okay. So you can see that you now sum this one. That will give us what? If you sum all these ones, that will give you what? I think that will give you around 4 point something, right?
Yes.
4 point. 4 point what?
5 have 4.52.
52. So this represents your chi-square value. So in effect, what you are saying that your chi-square statistics is, you know how we write it, right? Let me write it this way. So that will be your chi-square value. So this is just the test statistic that you are supposed to calculate. So you can see that they said, do the data indicate any significant preference among the 4 colors? Test at 5% level of what? Significance. Mm. Hello. So you see, this is exactly what the situation is going to be now. You see that this is just, I'm not solving the question in its entirety. I just went through some aspects of it that would demand a lot. This is just the test statistic itself. But you remember that if I'm supposed to properly do or solve the question one, A part, I would have gone through the hypothesis testing process, whereby I will have to state the null hypothesis. And the null hypothesis, based on this question, the question said, did the data indicate any significant preference among the four colors? So the first hypothesis, or which is the null hypothesis, is that there's no significant difference in the preference for colors. In the There's no significant preference among the colors. Do you get it? There's no significant preference among the colors. Then the H1 will be that what? There's a significant preference, or the preferences for the four colors is significantly different. Do you get it? That would have been the alternative. There's a significant preference among the four colors. Or if you are stating the null hypothesis, there is no significant preference among the four colors. That would have been the null hypothesis and the alternative hypothesis. The second one would have been, the second step would have been that I'm stating the decision rule, whereby I will say that if the chi-square calculated is greater than chi-square critical, we reject the null hypothesis. Then the third step would have been what we have done here. Please, I hope you are following. This would have been the third step, whereby we will now test the test, we will now conduct the analysis, right? Then the fourth step would be when we are interpreting this test statistic, when we are now interpreting it. Now, how do we even get the test statistic for this one? Let's all open our, uh, standard table, the chi-square table. Let's all open our chi-square table. The charts, just like the z-test and then the t-test, the table, so that we learn how to read the test statistic. Is somebody listening to me?
Yes, dog.
So I also need the feedback, oh, my sisters and brothers. I need the feedback, okay? Because if I didn't hear from you, it's as if I'm cut off from online.
Okay.
So I need the feedback.
Okay. Thank you, sir.
Don't tell me okay without saying anything. I know you can just do that, and then before I realize, I'm alone in the class. So have you opened your statistics book? This one, I'm picking it all the way straight from online. Let me see if I can just copy the image and fix it somewhere in the slide so that it becomes easier for me to read. Yes, but I hope you have gotten the chart I was talking about. If you go to the end part of the book that I share with you, you should be able to see it there. Have you gotten it? I know you will not get it. You wait for me to project it first. I know my people. First, Ellie,
Hello, sir.
I thought it's the guys that will dog me. I don't know the ladies who also dog me like that.
Sorry, sir. I'm taking care of your daughter. Go and buy a
Me,
biscuit.
my daughter. I don't know what you are talking about. Oh. Ellie, Ellie,
Hello,
continue to
sir.
be laughing. Respond to the question. Don't be laughing behind us. Have you opened yours?
Please, I'm searching
Don't
for it.
search for it fast. This is what I was talking about. Let's say, for example, have you all seen this one?
I'm
Yes,
quoting man.
Remember, we said that the chi-square test is a positive test, right? Or a skewed distribution test, right? Now, you see what we have here means that you need two things for you to be able to check for your chi-square values, the critical values. What are the two things you need here from the table? The table you can see. What are the two things that you need to be able to read your chi-square table?
The
What are the two things you need?
degree of freedom and your alpha value.
And then what?
Your alpha value.
That's all. How do you calculate the degrees of freedom?
So for categories, it is the number of categories minus 1.
Mhm. So in the case of what we have solved, how many categories do we have?
There are 4.
So what is the degrees of freedom?
So to be 4 minus 1, which is 3.
Perfect. I'll ask the question again. Who is here that cannot do that simple thing?
Doc,
Remember
please.
that was the first, or I should go over again.
Yes, please. My network had some hitches, so I couldn't get that portion
Now,
well.
you see, when we solve the chi-square, there are two classes that we are talking about. You see one here that they give you two categorical variables,
Oh,
right?
yeah.
Tell
Yes.
that we have watch preferences, whether you like analog, digital, or you are undecided, and then the age, which is in categories, right? So these are two categorical variables. This particular one, if you want to calculate the degrees of freedom, you remember the degrees of freedom is measured as what?
Yes, Doc.
R minus 1 times what? C minus 1. Do you get it? That way, we are talking about the number of rows we have here is 2, right? 1 and 2. And the number of columns that we have here are 1, 2, and 3. Have you seen that? So this is what we can use to calculate the degrees of freedom when we have two categorical variables or when we have a contingent table or a cross tabulation. You get that? But in the case of this, when we have this kind of example, when we assume equal proportions, the degrees of freedom is the number of what? df is equals to what? K minus 1. Have you seen it? That is, let me write it down here for you to see it very well. Let me write it somewhere here so that the degrees of freedom is equals to K minus 1. Do you get it? And the K over here is the number of categories. 1, 2, 3, 4. Please, do you get it? Sometimes it may not be written like this. It may be written in a vertical form like this. Do you get it? It may be in this one, but we are looking at it in terms of category because we are talking about one thing. This one, we are talking about only watch preference. colors. So the variable in itself is colors, but then we have different
The color.
4 categories. Those that are red, green, blue, and yellow, right? So in that case, when you are calculating the degrees of freedom for this one, it is k minus 1. So please and please take note of this very well, because these are the two confusing aspects of getting your degrees of freedom when you are dealing with the chi-square. One, you will just use the k minus 1 when you are using the equal proportions for and then subtract for the expected values, right? Then the second one, when you are talking about contingency table, right? When you are talking about contingency table or the cross tabulation. Please, I hope we can all do this. So in the case of the second one that we have solved, it is actually k minus 1, which is 4 minus 1, right? So in that case, it will be 4 minus 1, which is equals to 3. The next thing that we need is these things that we need at the top here, which are our alpha level, right? And in the question, we are being told that our alpha value should be what? Just remember this figure that we had here, which is what? 4.52, right? Let me see if I can clean these things. Okay. So what we have in here is basically the test statistics that we want to just remember so that we will use it probably in our conclusion. So I believe you have gone through this one already, so there's no need for me keeping them so that we have a clean sheet for us to read very clearly. Uh, okay. So they said, do the data indicate, any significant preference among the 4 colors? We should test this at what? 5%. You see, they have indicated it over here at what? 0.05 level of significance. So that is our alpha value. In some cases, they will tell you what, test this at 5%. Take note that 5% is the same thing as what, test this at 0.05 level of significance, right? So once you have here, then 3 is the one we are going to trace over here on this line, which is on the vertical axis, and then on the horizontal, we are going to locate where 0.05 is, and 0.05 can be seen here. This is our 0.05. So we trace that, right? We trace that all the way to this. And so we can easily see that this is the what? This is our
Critical
test
value.
statistic, which is the critical value. And remember, our test statistics, when we measure it, we said that our chi-square value, the one we calculated, we have what? 4.52.
Yes.
Is it not 4.52?
Yes, Doc.
And you see, so this is the calculated one. So that is the calculated. Now the critical one, you see that 7 point what? 815.
One.
So based on this one, do you think we should reject H naught or we should fail to reject H naught?
We fail to
Why?
reject. We fail to
Why?
reject because there's no significant difference in the distribution of infants among the colors.
There's no significant difference in what?
And the distribution of infant among the colors.
Is it infant among the colors or the colors among the infants?
Okay.
So you see, that's exactly what, that is the kind of interpretation I was trying to avert your mind to some time ago that the politicians do, right? The same thing you are talking about, but it means completely different thing if you don't put it in the right perspective, right?
Among them.
So we wanted to see if there is preference. If there is preference, the preference among infants are significantly different or they are not significantly different,
No.
right? So since the calculated value is less than the critical value, we conclude that the test is not significant and hence we fail to reject the null hypothesis and conclude that the preference of colors among infants is not statistically different. I'll take it one more time. Since the calculated value, which is 4.52, is less than the critical value 7.815, we say the test is not significant and hence we fail to reject H naught. Since we have failed to reject H naught, we conclude that hence there's no significant difference in the preference of colors among what infants. Please, I hope you get this or you have written it down. Since the test is not significant, we fail to reject the H naught and conclude that there is no significant differences in the preference of colors among infants. Again, this has gone to emphasize the point that oftentimes they say that children or infants like colors, right? But in terms of determining the preference for colors, they don't really have preferences. So far as the colors are bright enough for them to catch their attention, that is what they are interested in. I hope you've seen that. That is what they are interested in. That is what they are interested in. So these are some of the things probably you may be asked to. Now you see this one also. This is another type which looks similar like what we just did, but I'll tell you why this one is different. Let's read the question. The question says automobile insurance is much more expensive for teenage drivers than for old drivers. Do you know why? Because they think that the younger drivers, they are more exuberant and they can take more risks than the old people, right? So accident among the younger ones seems to be very high. That is why automobile insurance is much more expensive when you are a teenager than when you are what? An old driver. And again, an old driver is thought of as having much more experience, and therefore his accident level is going to be reduced or is lower compared to a teenager whose experience is not as high as that of what an old driver. Do you get it? So in this case, you see that we are not really interested in how old the driver is. We are looking at how experienced the driver is. Now, to justify this cost difference, to justify the cost of the insurance, right? The insurance differences. Insurance companies claim that the younger drivers are much more likely to be involved in what? Costly accidents. To test this claim, a researcher obtained information about registered drivers from the Department of from the Department of Motor Vehicle, which we call over here the DVLA, right? and then a selected sample of N equals to 300 accident reports from the police department. Now, the Department of Motor Vehicle reports that report the percentage of registered drivers in each age category as follows. So in fact, they are saying that 16% of are the younger ones that are aging below what 20 years. That means of all the drivers that are registered with the Department of Motor Vehicle, they notice that 16% of those are having age of less than 20. 28% of them are between 20 and 29 years. 56% of them are more than what? 30 years. So we want to, based on this information, we want to test whether there is a differences in what? Their age across, whether there is significant differences in the, the cost of insurance across these two groups. Please, I hope you get that. Now, let's read the actual requirements. Do the data indicate? You see that they didn't tell you straightforward that test the hypothesis. They are just asking you, do the data indicate that the distribution of accidents for the three age group is significantly different from the distribution of drivers? We should test this at 0.05%. With this, it's a very straightforward question that within 5 minutes to 10 minutes, you might be able to even finish this. Right? Now, the first thing that you need to do is to, first of all, indicate your hypothesis based on this question. And remember, what was the claim that is indicated here? It says that do the data indicate that the distribution of accidents for the three age groups is statistically or is significantly different from the distribution of drivers. So you can see that your null hypothesis could be simple, right? Can somebody try and indicate or state the null hypothesis for me? Out of this preamble, the A part. Can somebody try stating the null hypothesis for me? Eric Poku, Asamoah,
Doc,
can you help us state that hypothesis?
mm,
If you can't, just look for your enemy in the class and then point him to answer it.
they are all my lovers. So
Uh, just then you yourself answer it. If you cannot get any enemy from the class, then answer it yourself.
my sister Fossey help me.
Now, for is your enemy. You just
No,
confirm that.
it's my
For
sister.
let's go.
No.
For is not
Doc,
listening to
please,
us, so maybe you.
Okay, Ellen will help me.
Hmm. Ellie, your name has popped up. I'm not the one that mentioned it. That's good. Ellen,
Sir, please, I'm not feeling well.
but you know how to laugh. Ellen, Ellen,
Sir,
don't lie to me. Please just answer the question. We have done that hypothesis testing, how to state hypothesis, not an alternative, right?
yes, please.
In the just ended question, I stated how I indicated how you should state that hypothesis, and I even give an example. This is just an extension of that question, a similar thing. Look at the claim. Read it for me. The A part. Ellen, read it.
Do the data indicate that the distribution of the accidents for the 3 age groups is significantly different from the distribution of drivers?
So based on this, and you know that alternative hypothesis is null hypothesis is the hypothesis of the status quo. That states there is no difference. And the alternative says there is a difference, right? So based on what you just read, how do you think are they testing? They are testing whether there is a difference between some distribution, a distribution between what? Accident drivers across the 3 groups, age groups, and the what? The drivers themselves. Whether the age, the distribution of accident varies across the different age group for the different drivers. That is what they are interested in. So based on what you yourself you have read, what do you think would be the null hypothesis? You see what I have underlined, right? You see what I have underlined?
Yes, sir.
Indicates that the distribution of accidents for the 3 groups, for the 3 age groups, is statistically different from the distribution of drivers. So you can just state in your null hypothesis that what? The distribution of accidents for the 3 age groups, right, is not significantly different from the distribution of drivers.
Okay.
So that the alternative will say that the distribution of accidents for the 3 age groups is statistically different or significantly different from the distribution of drivers.
Okay.
This one is just the word, just the English aspect. But in terms of the content of what you should put there, is right in front of you. Please, do you get it?
Yes, sir.
This one is right in front of you. So in that case, we say that what? Distribution or what? Distribution of what? Accidents for the 3 age groups is not different from the what? The distribution of the drivers. Is that not it?
Yes.
That's all. The distribution of accidents for the 3 age groups is not significantly or is not statistically different from the distribution of what? Drivers. Then what do you think will be the HA or the H1?
That
The
one
only
will
thing
be,
that will change is that it is different, right?
yes, yes.
It's statistically different. That is all. Then you move to the next point or the next, I think over here, I think I put some text over here. So the distribution of automobile accident is the same as the distribution of registered, driver. That is another way of stating it. Or the distribution of accidents for the drivers is the same across all the age groups. If it is the same, that means there is no significant difference between them. Is that not it? Then another way of stating the alternative also is that the distribution of accident for the driver is not the same across the age groups. In that case, we are just trying to mean that there is a significant difference in what they are not the same, because the distribution of the age is statistically different from the distribution of what the drivers. Now, the reason why I take this question as important for us to solve is that, look at this. The third step, you know how to state that already. When the chi-square calculated is greater than the chi-square critical, you reject what? Reject
The
H
null.
naught, right? Right. Now, the step 3, which is the C step stage, is what? Compute the chi-square test, right? Or analyze the data, right? Right. Analyze the data. Is that not it? Now, this data that we are going to analyze, you see that these are the observed values given to you, right? In the case of this one, what do you think would be the expected value of the 68? What do you think would be the expected value for the 68? Those that are age below 20, what did they say over here? What did they say here?
16% are below.
Yeah, 16%. So it means that you have to calculate 16% of this sample size. Because they say a total of n equals to what?
It's 300.
300.
It
48.
48. So means that the expected value for this is 48. What about the age cohort 20 to 29? What is the percentage? They are 28%, right?
Yeah.
Is that not it?
Yes,
They
it
are
is.
28%. So 28% of the 300, what do you get?
$84.
You get what?
$84.
84.
84. Exactly. Then the last one will be what? If I add this one to this, plus
168.
136. One was
68.
like this, right? So it means that these are the expected value. So while this is the O, the observed value, these are the expected value. So if you have this expected value and stuff like that, what do? You just continue to subtract the differences, square the difference, and divide it by the expected value, and sum the results. Is that not your chi-square calculated value? So this is very, very straightforward. In this case, what do you think will be your degree of freedom? What will be the degree of freedom here? In this one, should I call somebody again?
So 2.
2. Let
Yes,
me
sir.
see if this guy believes it is 2. Let me see if who. Let me see if Pius believe that it is 2. No, Mark.
Sir, I said 2.
It,
That 2 is
you said 2. Pius,
yeah, 3 categories.
Pius,
It is true.
Pius. Why do you think it's 2, Pius? Pius, why do you think it's 2?
It is true.
Pius is not with us.
Yeah.
Pius is not with us. You can all testify to that, right?
Yes,
Isaac,
sir.
Odru, do you believe it's also is 2? Yes, sir. Why do you think it's 2? What is the formula for calculating the degrees of freedom in this case? Hello.
Yes, sir.
So even if you don't know, you can't even tell me. Okay, let's continue. Helper no grable. In this case, it's just k minus 1 as we stated, because the number of categories minus 1.
It's 3.
If it were to be a contingency table, it will be r minus 1 by c minus 1. So that is done. So in that case, so the next question is that write a sentence demonstrating how the outcome of the hypothesis test would appear in the research report. In fact, when this question is being asked, all what I'm interested in is that what are the important things that you are going to report? All you have to report is that the conclusion bit is the most important thing, right? The conclusion bit is the most important thing, whereby you re-quote the test statistics and then the critical value, and then you now interpret those values for me in the what? The last part over here, there. That is what I'm interested in. In this case, you see that we have a contingency table over here. This one, the way for calculating the degrees of freedom is what? The number of rows. How many rows do we have? 2. So it will be 2 minus 1 times. How many columns we have? 4, right? Minus 1. So it will be 1 minus 1 times what? 3. That will give you 3. So this is the degrees of freedom in this case. Now, if you read this question very carefully, you realize that they say if you use alpha value of what, or a significant test of 5% or 0.05 level of significance. So you can use this to cross-check your chi-square value in the table, and you should be fine with that. So that is just a quick, should I say a quick, or that is just an overview of what we have done last week. And I'm expecting you to be able to go through it thoroughly. Please and please, it is your duty to solve these questions. I've already done justice to almost all the questions by giving you all the important things you need to do. It's just that because we don't have a space on the the online space to be able to solve them one after the other or chronologically. That is how come we are unable to do that. But with this demonstration, solving them, you should be able to do that when you read through the question. Please, I hope you are okay.
Yes, sir. Yes, sir. You're perfectly okay,
Now,
sir.
other than that, we should start with this aspect of the topic. Remember, we are left with 2 more topics to go, right? ANOVA and then correlation and regression. It's most likely that we will not tackle the regression analysis, the correlation and regression. It's most likely. So let's look at the analysis of variance, simply called ANOVA, right? So anytime you see ANOVA, it's analysis of variance. You are just analyzing the variations, right? Now, what are the key things we want to know? We want to know the concept of analysis of variance in itself, to know the 2 types of analysis of variance, and to know the assumptions that underlies this analysis of variance, and to see the steps that we can go through to be able to compute the analysis of variance. Now, the moment you hear analysis of variance, you should also be thinking about another kind of distribution. Remember, we've looked at the Z distribution. We look at what? The T distribution. And the T distribution, remember, the Z distribution, remember the things that we need to calculate the critical Z value. You only need the what? The proportion, right? The area under the curve to be able to trace the critical Z value. Is that not it? When we look at the T value, we need only 2 things. We need the degrees of freedom and then what? And the alpha value. When we came to the chi-square distribution, we needed 2 things: degrees of freedom and then what? alpha value. Is that not it? Now, we will now have a different kind of distribution, which we call the F distribution. That is what we use in testing the ANOVA, the analysis of variance. In this case, when we are going to look for the critical F statistics, F statistic, we are no more interested in using only the degrees of freedom and then the alpha value. We are rather interested in the degrees of freedom within and the degrees of freedom between. What are all those things means? You get to know in the GFU, right? Now, as a basic way, we say that when we have two categorical variables, we use chi-square test, right? What about if we are interested in, we have one categorical variable and one quantitative or continuous variable? It becomes difficult for us to go through that, right? Other than that, we have to use the T statistic. If it is a two-way categorical, the categorical variable is one, and then the continuous variable is one. And in that case, the categorical variable is just binary. Even the t-test can still be used. But if it is more than two categories, then the t-test is quite limited. Analysis of variance can help us to be able to do justice to knowing more about that variables and then how we can use it to do hypothesis testing. Now, the main question that we always ask is that do the mean of this quantitative variable depends on which groups of the categories of individuals. So, for example, in that case that we are looking at color, right? If you want to look at how color choice influences or if there is any relationship between the color choice of the children and the height of the child, you get to know that the height might necessarily correlate with the color choice or might not correlate with the color choice. So we would want to check probably between the age, between the color choice, let's say red and blue, and between blue and red, and between red and yellow, and between yellow and green, and between yellow and blue, and between yellow and red. Which of the which of does the age or the height of the child or the infant have any significant difference, or it is just by mere coincidence that there is a difference? So things of that nature is what the ANOVA is helping us to. So if categorical variables have only values, two values, right? That in that case, a simple t-test could be used for that. Let's say, for example, if I want to look at wage rate, remember wage is quantitatively measured, right? Somebody's wage can be 5,000 or 4,050 Ghana cedis, right? Somebody's wage rate can be 5,500. Somebody's wage rate can be $7,000 per hour, right? These are just quantitative in nature. Then the second variable is, let's say, sex, males and then female. So if you have male and female across a certain continuous variable like this, then the t-test would have been used for that. But if we have this one, the category, if the sex is more than two categories, in that case, if we are to be talking about, let's say, religious affiliation, religious affiliation. In this case, we can talk about Christians, right? Muslims, Buddhists, right? Buddhists,
Fetish.
atheists, and the
Deities of
stuff, or even traditionalists. You see that in that case, the categories are more than what? 2, right? If that is the case, then t-test cannot be most appropriate. The analysis of variance is what can be used in that case. Do you know why? The simple reason is that if it were to be t-test, t-test would have conducted the average wage of the student or the individuals and compare for males, and then the average of what? Let me say the average wage of men, and then compare that with the average wage of what? Female. You get that? So that it will check whether there is a difference between them or there is no difference between them. But in the case of when the categories are more than 2, let's say there are 3, we have Christian, we have traditionalists, and we have what? Muslim. In that case, you see that it is going to be difficult for you to look for the average value of what? The average wage of what? Christian to average age of what? Let's say traditionalists, then average age of Christian to average wage of what? Muslims. Do you get it? Then we can also have the average wage of what? Traditionalists and average wage of what? Muslims. Please, do you get it? So that gives us about 3 different combinations. But the t-test can only help us to compare the mean of these 2 groups at a time and not within these ones. So in this case, it is going to be important, or it's very important for us to take note that when the categories are more than 2, then the use of these statistics to be able to evaluate whether differences exist within a certain quantitative or a continual variable become problematic and difficult, right? Now, let's look at this. Subject, 25 patients with blisters were chosen, right? We have a treatment group A, treatment group B, and we have also a placebo, making that treatment having 3 options, right? The individuals that are treated with vaccine A, individuals that are treated with vaccine B, and those individuals that receive a placebo. Placebo is just a kind of a treatment that looks as if you have been treated. A typical example is, let's say that I'm conducting a study that I wanted to check if the paracetamol can cure headache, right? And I have selected 3 people, 10 people. For 5 of them, I can give them the actual paracetamol that I'm trying to test whether there is a difference between them, whether it can cure the headache. Then the other 5, I may decide to give them something else that look as if paracetamol, but in actual sense, it's not the paracetamol that I'm testing. The whole idea of doing that is that so that the individual who do not receive it should not portray a behavior that will contaminate the results. Because if they know that they have not received any treatment, they will feel some way. Maybe even by mere fact that they know that they have not received any paracetamol can influence their health status in a certain direction. So we also give them something that looks as if the treatment item or the paracetamol in itself, but in itself, it is not a paracetamol, right? It might be just the standard starch with something bitter that we put inside, right? And then one group will take the actual paracetamol. That thing that we give to them that look like the actual paracetamol is the placebo that we're talking about. Now, we have collected data. You see the data on the vaccine A, B, and then the placebo, right? So the average is 7.25, The average for the person B is 8.875, and then the average for the placebo is 10.11. Now, you see what we have here is that are these differences average of the treatment A, average of the treatment B, placebo, and average of placebo. I think it's actually supposed to be average of A, average of B, and average of the P, which is the placebo. Are they statistically different from each other? Now, for formal investigation, we normally will use the side-by-side box plot to be able to show some of these things and to see how they varies, right? Whether the differences between the groups are significantly different from each other depend on three things. One, whether the means are different, the standard, whether the standard deviation of the each of the group is different or the same, and then whether the sample size for each of them is the same. In this case, you can see that the sample sizes are not the same. You can see that the sample size in the case of the first one is about 8. 1, 2, 3, 4, 5, 6, 7, 8. The 8, right? 8 samples were used here. The second one, 9 samples were used, and the third one, 10 samples were used. So you see what is happening here. So in this case, when we have these three averages, then the analysis of variance can help us determine the p-value from the S statistics, whereby we can use the S statistics to be able to determine that. The graphical way that I spoke about is something like this, where we're talking about the box plot, right? The side-by-side box plot to be able to see if those who receive the first treatment, their average is around here, right? 7 point something, right? Those who are received 2, theirs is around 8 point something. And those who uses the placebo, theirs is 10.11. So this shows us with the different side-by-side comparison among the different groups, right? Now, what does the ANOVA do to this data set? We first of all, in simple terms, we always use some of these hypotheses. Of course, remember it also goes through a similar way of hypothesis testing if you want to. So the first thing is for you to also state your hypothesis in that case. However, because we are talking about the average of these three, whether they are equal or not the same. So in that case, you say that the mean of all the groups are equal. That is how you state the null hypothesis. The mean of what? All the groups are the same. Then the alternative will be that at least one of the group is different. Take note of this. If the null hypothesis in this case is saying that all the groups are the same, don't say that all the groups are not the same as the alternative. Do not say that. This one, you say that at least one of the group is not the same. Whether A is the same, is not the same as B, or the B is not the same as P, or the P is not the same as the A. That is how we go about stating that. Now, note that all the mean are not all the means are equal. Doesn't say how much or which one differs. That is the unfortunate aspect of stating this kind of hypothesis. It does not really tell you how much is the magnitude of the differences. It just tells you that they are not the same, or at least one is not the same. We should note something that we usually refer to the population as groups when doing analysis of variance. Now, what are the different types? We have two types, one-way ANOVA and two-way ANOVA. Now, the one-way ANOVA, we are looking at a statistical technique that is used to compare the means of three or more groups or treatment to determine whether there are statistically differences among them. It is an extension of the T statistics that is used for comparing what the mean of two groups. So in that case, you are just comparing the mean of the groups that we're talking about in there. Then the two-way ANOVA, that way we are looking at it's an extension of the one-way, and it is used when you have two independent categorical variables called the factors that you want to investigate simultaneously to understand their effects on a continuous variable. So in that case, you may also have three variables. Two of them are categorical in nature, and you want to analyze them, how they respond to changes in the continuous variable, right? Changes in the continuous variable. So the one-way ANOVA test, we're saying that it tests the differences in the mean of more than three groups, or which is three categories, right? And can be done when t-test can be done by t-test, but should be discouraged because since t-test compare two means at a time, the other means are ignored. Do you get it? So it means that when the categories are more than two, and you decide to use the t-test will test it all right, but it might only be testing the average of the weight for the first treatment and then the average of the weight and the second treatment. What about the average of the weight for the first treatment and then the average of the weight for the placebo? Or do you also think about the average of the weight of the second one and then the average of the weight and then that of the placebo? You get it? So it becomes very important that even though the chi-square, the t-test can be used to test the hypothesis for when there is more than two categories, it is not advisable because that approach only, you know, it only captured only one of the differences, not the other two. Okay, let's look at this. Some assumption. We should know that each group is approximately normal. That is, check this by looking at the histogram and or the normal quantile plot, or use an assumptions. Use assumptions. And it can also handle some non-normality, but not severe outliers. Also, independent of the samples for each groups are supposed to be ensured that they supposed not to, or each of the samples should not depend on each other. If not, it can bring about some level of correlation that might mar the significant impact that we are trying to observe. Variances and standard deviations of each group are approximately equal. So the rule of thumb for this particular thing, that is the variance to standard deviation ratio is that 2 to 1. It shouldn't go much beyond this. That way it will have caused a little bit of problem. So this is how to conduct the normality test. I didn't spend much time on that. And then in terms of the standard deviation check also. So in this case, you see we have the statement A, B, and placebo P. So we had already seen that the first one had a mean of, is it 7 point something? 7 point something? Is it 25 or so? Then
250.
8 point, is it 7 point what?
250.
250.
Yeah.
Then 8 point what?
875.
75. And then the third
8.875.
one is what? 10.11.
Yeah.
10.11, yeah. So you see that over here we are only comparing we are not only comparing the highest versus the smallest or the smallest versus the highest. They will compare the largest and smallest standard deviations rather, right? That is what is done in practice, right? Such that we expect that the variance ratio should be 4 to 1, right? So some of the notations you might want to take along or keep note of is the fact that N is the number of what individuals, all individuals in the sample, which we already know. The L is the number of groups. The X is the mean of the entire data set. The X bar is the mean of the entire data set. Then for each of the group, the NI is basically the is basically the value for individuals versus that of the group. So if let's say individuals are within, right, let's say a religious affiliation. So for individual scores over there, which are the XIJ, we are looking at each individual, what values are they scoring for each of the different groups that they are in, right? But individuals in itself, when you look at the count, would form part of the NI. Then we also have the X bar over here, which is just the mean of the group mean. But the Sij is just the values, the individual or the values of the individual across each of the group. Then the standard deviation will be the Si for each of the groups. So this is basically, of course, you are not too new to this formula. Is anybody new to this formula? I will go and take his school fees for him gracefully. We are aware of this formula already, how to capture the standard deviation. Take note, if it were to be population, it will be minus just divided by n. But if it is for a
Sample.
a sample, then we can look at it from this angle. What are the steps do we go through to do the one sample ANOVA? These things, we can always group them into those four. You know this already. State the hypothesis, deny, and alternative. Is that not it? When you are selecting the level of significance, this one, this, and this, they are all this and this form part of the, the second stage, which is the decision rule, right? Then we determine the test statistic as the third stage. Then when we select the sample and perform the calculation, this one should be added to this. So you can see that this and this Let me see if I can regroup this quickly here. So you see that the first step, let me regroup this for you, right? I'm trying to regroup this for you, right?
Okay.
Let's say the A. So this one, select the second one, B, C, then D. So this one, I'm just combining that to determine the test statistic. So this is what you're going to do over here. So if you are determining the decision rule, you might as well be part of this, right? And then you select the samples and perform the calculation. This should be part of this. So you see that these stages can just be regrouped under 4. Please, I hope you've seen it.
Yes, sir.
So we can regroup that into this 4, steps, right? Whereby with
Okay.
the null hypothesis, we select the test statistics, or we select the significant level, or better said, determine the decision rule, right? Because you cannot use the decision rule without indicating the level of significance, because it's the level of significance that you are going to combine with the degrees of freedom to be able to look at the critical values. And those critical values are those that you use in the statement of the decision rule. Then you determine the test statistics by selecting the samples and performing the necessary calculation. Then the last one is for you to make the decision itself by way of summarizing. Let me add this to summarize, interpret. So you interpret, summarize, and conclude whatever on the results, right? That is what you are going to do. Now, how does this thing even works in principle? You have to take note of this. We have what you call, you have to measure two things, right? In ANOVA, which measure two sources of variation. And remember, I told you analysis of variance basically means what? You are analyzing the variation, because variance means differences, right? Variance means differences. So if you are doing analysis of variance, you are just doing analysis of difference. You are analyzing the differences, right? So you do what we call the variations that is between the groups and the variations that are within the groups. Now, for each data value, look at the difference between each group's mean and overall mean. Now, the extent to which the data point or observation is different in different groups or categories varies from one another. So how do we do that? You see that these are observations. These are observations, right? So you know that the observation for each of the groups divide minus each individual value means, then you score it. So let's say, for example, if I have all the students in this class right now, right? I can calculate the mean for you, and that mean for this sample could be the X bar. But the XI bar will be that if I pick out of 5 people in this room and then I calculate the mean for it, that would have given me the XI bar.
The sample.
Then we also have the variations within the group itself. That is for each data value, we can look at the differences between the values, and then the mean of each of the groups. So within each group, this is out of the class that I have the mean. Let's say the class mean age is what, 30, right? And I pick, let's say, 5 of you, and I calculate the mean for this one. You see that the 5 of you that I've selected, the mean is no more for the group, but the mean is for the subgroup that I have conducted, right? So for you to calculate the variations within the group is for us to subtract the but if you are looking at the variations between the group, you look at the ages, the average of the ages of the individual.
Please, Doc, I can't see you. I don't know that from my end here.
In the entire class. Let's look at it from here. Hey,
Yeah, we can see. Yeah.
so I'm looking at between the groups, right? So let's take, for example, how many are you in the class right now?
We are 12.
So out of these 12, let me write 12 here. Number of people in the class, 12, right? Let's say out of this, let me put it at the top here. N is 12, right? That is the total number of people in the class. What is the average age that we have there?
You said 30.
Let's say they are 30, right? Now,
Yeah.
I will pick, what would I do now? Let me form 3 groups out of this class. Let me form 3 groups. Let me form 3 groups, right? Now,
Yeah.
these 3 groups are these categories that we are talking about, right? I'm forming these categories. So let's say that one group like color red, one group like color black, and one like color white. So those who like the blue, so let me put B over here. All those who like the blue, their average age is what? Give me a figure.
8.
Then all those who like the color white, what is their average age?
5.
26 or 5. Then let's say all those who like color yellow, what is the average age? 21.
21.
Let me ask, the first one should be 18. So you see that, let me see if I can remove the last part here. Now, so what this one is saying is that between the group, you see that the first one that we had is what? Is the overall mean, right? So between the groups variation is for us to look at the mean of each of the groups, how they are different from the mean of the overall. So in that case, it would have been what? 30 minus what? 18 minus 30, right? Squared. Probably plus what? Let's say the next one will be 25 minus what? 30 squared. Then the next one will be what? 21 minus 30
squared.
30 squared. That variations will give you between variations. Now let's come to the second aspect. Within the variations, we are saying that this age that we are talking about, you see the 18, 25, and then 21. We want to now calculate the variations that exists within the group itself. Now, the group that we have over here for the 18 is those who prefer the blue. The one that we have for the white is those who prefer the white. And the white is the one, those who prefer what?
The black.
Yellow. The yellow, color yellow. Now, what we are now coming to do with the variations within the group is that we will now subtract the individual ages from these figures that we have. So in that case, we will mention the specific people in this age, in this group. Let's say 18. So now that 18 will be what? Let's say, what is the age of one of the individual in that group? What is the age of the
13.
individual in that group?
13.
So let's
25.
say 13. So let's say one of the individuals in that group is just 20 years old. You subtract it from 18 and square it. Then another person from that same group, right? Let's say he's also 18 years minus 18 squared. We can have another person which is 19 minus 18 we squared. Then we look at those who are white, right? And look for those who are within whose age were used to find the average of those 18. So average of those 25. Maybe somebody was 27, so minus 25 squared. Somebody was exactly 24 minus 25 squared, in that order. So you can see that the second part over here, I'm just calculating the variation that exists within the group itself. Because that way we are looking at the individual's age as against their own group age. But the first one that we look at is the age of the groups compared to the overall group, the overall age group mean. Please, I hope you get the difference. Each of these things that we are talking about will have a different degrees of freedom. It means that even from the word go, you saw that we are comparing this one, the age of the individual, the overall individual, by the number of groups. Is that not it? So in that case, it is n. To get the degrees of freedom for within, it will be what? N minus k. Because how many groups over here? It would have been 3 groups. And the n would have been the total number of sample, because the 30, the average of 30 that we calculated is for every individual in the entire class. Is that not it? So in that case, the degrees of freedom for that would have been what? N minus k. Then the second aspect, which is the within, you see that because we are comparing the individual as against their respective groups, it will be what? K minus 1. Do you see that? That would have been just the number of groups that we have, which are just 3 in this case, minus 1. So let's look at this from this angle. So once we are able to get that, once we are able to get the within, which is this thing that we see over here. Let me see if I can change the color for this one. So you see this formula here, and then this formula here. Once we divide them by each other, then we can get the variations within. So what we are doing over here is what we have here. So it means that between variations divided by within variations, that is going to give us what? Our F statistic. So this will give us our F calculated. That is what we have here. Have you seen that? So this is our F statistic. Another way of looking at this is that the between that we says that it is what? Sorry, it is that we have this the square, right? So it will be I. Oh, what's happening? I'm using eraser to draw, write minus squared. So you see that should be divided by the degrees of freedom. That is, will be what? N minus K. Do you get it? Then those within, which is the residual, will be what? The individual Ij minus Si bar square divided by K minus 1. Yes, K minus 1. Because that is going to give me the degrees of freedom for the categories. And once you are able to do that, the top part, which is within, gives you what we call the what? The mean sum, the mean square between, and then those below it will give you the mean square within. The mean square. So you just the abbreviation that I use for this. That's the mean square between, and then the mean square what between over here. Now, remember also that a large F is an evidence against each node, each O, which means that when F is very large enough, it simply means that you are going to reject each node. It's a very sensitive test. This particular test is very sensitive because the moment your F statistics is a little bit large enough, you can see that there's a significant difference in the what in your test statistics, for which you have to reject your H node, HO. That is why we says that a large F is an evidence against H node, since it indicates that there is more differences between the groups than within the group. Now, the analysis of variance, you can see, for example, whenever we run regression analysis, we can have SS and we have what? So this is the ESS, the ESS, sorry, the ESS, and then we have the RSS. RSS is simply the residual sum of square, and then ESS is the explain sum of square. Once you divide, so these are the SS, right? So if you divide this by these degrees of freedom, you would have gotten MS. That is the mean square. That is why when it comes here, I was referring this to the what? The mean square for the between, and then the one down here is the mean square for within. So you also do same thing for this one, which is this divided by this, you get this. Once you get this, divide this by this, you get F statistics this. In this particular case, you can say that your F statistics is equals to my SS for the treatment divided by the degrees of freedom for the treatment, right? All divided by the SS for error divided by degrees of freedom for error is equals to 34.74 divided by 2, or divided by 59.26 divided by 22. And that is going to give you what? 17.37 divided by 2 divided by 2.69. And that all gives you 6.45. This is the F statistics that we're talking about. So you see what we are having here. You see this?
Yeah.
So these two would make up, these two will make up this. and these two will also make up this. That is what we are talking about. So in a nutshell, let me see if I can clean this. So you see over here, what we are having is that what we are having is exactly what we have indicated over here, but in a different way, right? Some will ask, how then can I calculate some of these things based on what we have here? You see, within over here, this is exactly what is here. So this one is just the same as the summation of SI bar minus summation of S squared. And this one is also like summation of IJ minus summation of SI bar squared. That is all what is being written here. If you are lucky enough and you go to the exam room, they may give you these formula sheets, but don't bother yourself so much about this, because once you understand this concept that to calculate something like this, and if you are able to take one object example, you can easily see some of these things. It's not difficult. So you see what we are also talking about here. If you have used data, for example, to do this example, or you have used some of these other software to do some of these things, you see that this is likely what you are also going to get. This is what you are likely to get. So you see that we have the model sum of square, right? We have the model sum of square, which is our ESS. You have residual sum of square, which is our RSS. Once you divide them by the degrees of freedom here and degrees of freedom here, you get these figures here. Once you divide the two together, you get this. It's as simple as that. Sorry, this is the you get this. That's 44.23. 44.23. Yeah. How many? How are these made? Right. We want to measure the amount of variations due to the between groups variation and within group variation. And remember, I told you that between the group variations is this one. That is the subgroup that we have, their mean value minus the main group mean squared of them. Then the within, we are saying that the individual values minus the subgroup mean squared, right? With the subgroup squared. Let's say, for example, let's say 5 people have, we have scores of 5, 3, 2, 4, 1, 8. Let's say 1, 2, 5. Let's say another one here. So 5 plus this 10, right? 10 plus 10, 20, 24. This is 24. How many elements? 1, 2, 3, 4, 5, 6, 7. 7, 24, 7. Let me see. This one is another 4. Let me clean 1. I want to make this just as easy as possible. There are 5. Let me clean this and clean this. Let me make this. Let If you add this two, it will be what? 8 plus 8 is what? 16, right? 16 plus 4 is 20. So let me add 5 to it. So this is the age of, let's say, 5 people in the class, right? What will be the mean value here? What is the mean value here? What is the mean value here?
So yeah, though divided by 5. 25 divided by 5.
5.
So that means we have 5, right?
Yes.
So our overall value is what? A mean is 5. Let's say we have taken another group. So let's say we have 2 groups, right? We have 2 groups. One of the groups have 5, 3, 4. Another group is 4, right? 8, and then 5. What will be the group of this one? So let's say we are having SI bar to be what? This one is how many? What
4.
will be the mean of that one?
4.
It will be what? 7 plus 2, 7 plus 5 is what? Divided by, so it will be 4. Then the second one is what? The next one is what?
5.6.
So let's say this is the second one, right? So let's say, let me add 2, I1, I2. This is what? 6 point what? That will be 6 point what?
5.6667.
5.667.
Yes, please.
So what we are saying over here is that when you are looking at within the group, between the groups, all what we are saying is that these values that you see over here, subtract it from the 5. So in this case, we are talking about 4 minus what? 5 squared plus, let's say, the next one is what? 5.667
6, 7.
minus 5 squared.
Wait.
Do you get it? That should
Yes.
give you the between. That should give you the what? Between. Now, for the within, what we are saying is that the individual values you see over here minus their respective what? Mean value. So in that case, it will be what? 5 minus 4 squared plus 3 minus 4 squared plus the other one is what? 4 minus 4. 4
4
minus
minus
4 squared.
4 squared.
Please, do you get that? Then also, so that will be for that plus, let's say the next one will be what? The next one, this is its mean, right?
Mm,
Will be what? 4 minus
minus
5 point what?
5.67
667
squared.
square plus
8
8
minus
minus what?
5.67
5.667
squared
squared
plus
plus
5 minus
5 minus 5.67
5.67
squared.
squared. Uh,
So that should give you the what? Within. And the first one rather will give you what? Between. That is the kind of idea we are using behind this. So this is a typical example of what we are seeing over here. So you see what we have here is that the columns that you see over here, these are for the different columns, right? Different groups. Is the groups that we are calling columns here. You know the number of counts for this one is 3. This one, the number of counts is 1, 2, 3, 4. And the number of counts for the last one too is what? 3. The number of counts to mean that how many elements are inside this one. This is 1, 2, 3. This one is 1, 2, 3, 4. This one is 1, 2, 3. Do you understand that count? Those are the counts. Now,
Yes.
when we sum each of them, we are 18, 23, and this. We want to get their respective, for how do you call it, averages. When we solve the average for this, is it not 6? Average for that is it not 5.95? And the average for this is 7.5333. Now we can calculate the variance for each of them. Is that not it? We can calculate the variance for each of these groups. That is what we are saying. And you know the variance formula, right? Normally the variance will be what? This squared. Is that not it? Or divided by n or so. Yeah. Or n minus 1.
1.
N minus 1. Is that not it? So these things that you see over here is what we are going to calculate. It's as simple as that. So in each of them, you have to know that the variance for this one would have been what? Since you've gotten the mean to be 6 in the first case of the first column, it will be 5.3 minus 6, right? Squared plus what? 6.0 minus 6 here plus 6.7 minus 6 squared. Is that not it? Then you divide it by 3 minus 1, which will be 2. That would have given you this. You do same thing for the second group, the third group, and then that is all. Let's look at this. All you are doing is to now use their sum of squares and then divide it by this, and then you be able to get the mean sum of square. They divide the mean sum of square by for the between, and then the mean by the within sum of square for the sum of square for within, and that will give you your F statistics. Now, if you go into the books, the critical F statistics, remember you have to know that this one, how many groups are here? Are there not 3 groups?
Yes, they
So
are.
in effect, how many n? So within, so for the between how do you call it? Degrees of freedom between, is it not n minus k? What is n? N is what? The number of
The
elements for all of them.
Yeah.
That would be what? The first one was 3. Is that not the count 3? The second one was 4. The third one was 3. So that would be 10 minus how many groups? Is it not 3 groups that we have? That would be what? 3. So it will be what? 7. Then what about the number of the degrees of freedom for within? Degrees of freedom for within. It will be k minus 1. And we already know k to be 3, which are the number of groups. Is that not it? Minus 1. Is that not 2? So means that our degrees of freedom for between is 7, and degrees of freedom within is what? 2. So all we have to go to is to go to our F statistics. So again, open your textbook and let's look for our F statistic. Let's look for our F statistic table. Let me see whether I can get one for us to use. Yes. Let me see if I can have that. I'm looking for one specific type. No, I'm not getting that one, but I'll try and see. There are some of them, they will tell you which of the axis is between and which of the axis is within, so that it becomes easier. That's the one I'm looking for you. Let me see if I can get that one. Um, oh, I'm trying to remember exactly the degrees of freedom within and the degrees of freedom between for the specific, some of them they even write it below it. I wanted to be sure if okay, okay, I get it now. So let me write it over here, so that it becomes easier for you to see. Let's say, so this is what I just, so this table that you see over here. So the top one you see over here is for the numerator. Numerator. Then I think, where can I write this one to get the denominator in there? Let me write it here. Let me see if I can keep it here. Denominator. Denominator. So we are done with that, right? So this is, let me turn this. Ish. Let me see if I can reduce this to 14. Please, I hope you are following. So let me say equal is the same as or between,
Yes, sir.
so that it becomes easier for or within, so that you can see quite clearly. Now, so you see what we have here is basically to say that this is what we have, that between and within, right? Oh, my thing seems to be. Mhm, mhm. I think you can now see it, so that we can talk about the between and then within. So you see that for you to be able to do the trace the critical value for S statistics, you need three major things, or let me say two things. But then you need the degrees of freedom and then the alpha value, right? Or the level of significance. But the degrees of freedom, you realize that you need two degrees of freedom, the one for within and the one for what? Between. The one for within and the one for between. And then you need the alpha value. So the one that I'm showing you over here is for only when your alpha value is 10%. Take note, if the alpha value is 10%, then this table is okay. But if alpha value is not 10%, please and please, it is not going to be the same. Take note. Within and between are not going to be the same. Now, you saw earlier on that we calculated the degrees of freedom. So let's say that we have the 2 degrees of freedom is what? In this case is what? The second one, this is the DF1, right? DF, DF2, and this is DF1, right? So the one is the degrees of freedom between, and then the DF2 is the degrees of freedom within. So if the degrees of freedom is within, between is 2, and then that is within is 7. At a 0.05% alpha value, you can see that we have to first of all trace our figures here first. We have to first of all trace our figures here. The numerator would have been 2, right? Let me use red for that one. We would have traced this figure for the 2, and then this for the what? The 3. So it means that this figure would have been what we are looking for. You see this figure? This is what we would have been looking for. Now, if you go through the book again, you might come across another Z value, F statistics figure that is using the degrees of freedom to be alpha equals to 5%. Let me see if I can get the 5% one for you. I think I have seen 5% one. Let me see if I can copy that one for you. I think this one is a much more complex table, which I can share this one with you. I think that will make things much easier. but you just have to open your eye to get it right. Hmm? Let me see if I can open this stuff, which is a compacted one. Hello, my people. Are you there?
Yes, Doc, we are
Yes,
here.
Okay. So let's look at it together. Can you see this figure,
Yeah,
please?
yeah.
I know it's very difficult to see it quite clearly, but I will try as possible to minimize the empty spaces so that you can see it. Can you see it? Can you see these figures?
Yes, Doc.
Can you see this one? I have moved to a different one.
No, okay, yeah.
You see the previous one that we saw. Remember the alpha value is what? 10%. Is that not it? And we had the
Yes.
numerator to be 2, the numerator to be 2, and the denominator to be 3. And the answer or the critical F statistics was 5.4. Is that not it? 5.46. When we come
Okay.
here, you see that at 10%, 10%, we would have used this column, these ones. I'm marking the 10% ones. You see, these are the 10% ones. Do you get it?
Mhm.
So if the numerator is 3, we have this, and the denominator is 2. You see that we have this. That means at 10%, it should have given us something figure like this. Somewhere, am I right? It should have given,
30.82.
let me see this figure over here that we had. 5 point, oh no, 10%. Oh, I'm using 10.10%. 10% would be this first one, the first one, sorry. I should have marked the first one. I have gone to mark the 0.5, 1%, 0.1%. This is what I should have marked. The first ones. You see, they are the 10%. The first ones are 10%. Have you seen that? The
0.1.
first ones are 10%. So it means that if we are crossing this one, if we are crossing that by this, it means that we are interested in this figure. And you see that this figure over here is the same as 5.1. That is our 5.415 thereabouts. Over here, it is much clearer when it's 5.6, 5.462 something. 4. Please, have you seen that? So I think this kind of table is more compacted and is easier to read. But it is very dangerous if you don't open your eye very well. Like I was also trying to, you see that I nearly pick a value that is not the 1%, the 10%. I was going to say select 0.1%. I was going to take 1% instead of the 10% that I'm supposed to pick. That's the danger with this particular table type. Now, if it is 5% in the question that we are solving, you see this one is what? Degrees of freedom is 2, and then the second degrees of freedom is 7. At 5%, it means that the second degrees of freedom that we are talking about, the next value you should take, it should be from these categories, right? Have you seen this? You have taken the values from this category, and 2 should also come from here, from these categories. So it means that the value should be here, within here. But remember, because we are dealing with 5%, we are dealing with 5%. 5% will be where? 5% will be this. Have you seen that? Five percent is this. Have you seen that? 5% will be this. That's 4.74, right?
Mm,
Please, have you seen that? That will be 4.74 for this one, because we are tracing 2 to 7. So if you go back, you see that that is exactly what was indicated here. And if I want to circle that with the yellow, you see this. Have you seen that? That is exactly what we are talking about here. So that is how you can also read the F statistics. So with the F statistics, you need 2 things, but there are 3 in disguise. You need the degrees of freedom. Let me rewrite it here. You need the degrees of freedom for 1, which is the numerator. It's the same as the numerator. Then you need the degrees of freedom also for the denominator. Then you also need the alpha value, or the level of significance, before you can be able to read the critical test statistic for the F statistics. Please, are you following?
yes, doc.
If you don't understand, you ask so that we.
Is willing.
I know some of you at this time. It looks like you are watching some movies. Simply because,
True.
because some of you are not writing, and unfortunately, you can't do mathematics or statistics like that. And some of you will bear with me. Ever since we started this course, you have never put a pen to paper before. You have always been watching. And how can you say that you want to understand? This one is not by magic. Please, do you get it? Some of these things you have to write it. Whilst we are also doing it, you are also writing, and you need that concentration. But some of you, you don't even know where you keep you don't have any jotter or notes for statistics. And you still want to understand it the way we are teaching it. That one, it won't happen as, it shouldn't be a magic. Hmm? So I'm just pleading with you that if you are the type that just listen to it without writing it, you have much more work to do by trying to go watch the video, sit down and work it out. Please, do you get it? Work it out. Let's proceed. So you see what we have done here. That had given us this sum of squares that we were talking about. Somebody would have broken down the same thing in this form. So you see that when we have the groups 1, 2, 3, look at this. Over here, how many groups do you have? There are 3 elements in the first group. Is that not it? 4
Yes.
elements in the second group,
And
and then 3 elements in the third group. When we went through this, you see the variance as this, right? They are trying to calculate the variance and all those things for you. Look at what is happening here. So you know that the groups that make up this one, they are what? They are 3 elements. So they form part of the first group. Is that not it? The second group, they are what? 4 elements. They make up the second group. Is that not it? And the third group, they are 3 elements. And they make up the third, group. Remember, the mean for this was around 7 point something. 7 point something. The mean for this was around, is it 5 or 6 point something? I think when we calculated it here, it was 5.95, right? 5.95. And then the mean for this is 6.0. And that of group 3 is what? That of group 3 is 7.533. 7.5333. Remember that. Now, see how the within was calculated and how the between was calculated. Do you see that? Now, you see that the mean for that group was this. Is that not it? Means that each element in that group will receive the same mean. Is that not it? The same way, each element in the second group will have the same mean, and each element in the third group will also have the same mean. But remember, the overall mean was what? 6.4. This 6.4 was the S bar that we calculated first. You remember the example that we gave? We said that the mean was 30. Remember that. That 30 is what we are referring to here over here as what? 6.44. Now, what is done over here is that we are seeing that the differences in the data within the group. Is that not it? So we are saying that Xij, let me write it much better for you to, so that, can you remember the formula for within the group? It is sorry. Let me use the green to write that one. It is Xij minus Xi
X bar.
bar. Do you remember this? Let me do this well. Do you remember this? So it means that what it's telling us is that simply it is just telling us that it's subtracting each of these elements. So these ones you see over here, where my red line is passing all those elements from the first group, you subtract each of them from what? From the respective mean, their own group mean. And that gives us minus 0.7 here, 0 here, and 0.7 here. You do the same thing for all of them, each of them with their respective one. Do you get it? Each of them with their respective one, each of them with their respective one. That's what
Please,
we
sir,
do.
point of interest, sir. Doc,
You said?
a point of interest, I think I want to be clear. Do you rather subtract the mean from the figure given, or the figure given from the mean? Because with respect to the formula that you quoted.
Look at this. I know what you are talking about. You see that when we write something like this, Sij, it is technically, it reads as the S bar, that is the X bar, right? It's technically to say that you are subtracting the Xi bar from the Xij. It's technically to say that you are subtracting the mean value from the observation value. But this one, what it means is that over here, which ones are the Sij? Identify the Sij from the group one for me.
The data site, I mean the 5.3, 6.1,
Exactly. So those are the Fij. So once you are doing the computation, you care less for those ones. Remember, it is also raised to the power 2, which is squared of it. And the F squared form is what is given here. Do you get it? When they do this, they do the square here. When they do this, they do the square here. When they do this, they do the square here. Do you get it? So you can see that the deviation, some of them will be minus, some will be positive, minus, positive in that order, right? But their square values will all be positive. Have you seen that? Their square values will be positives. So we just subtract this from that. This and that, this and that, this and that. That's what we did. This and that, this and that, this and that. That gives us these values. Then we take the square of these values to get these ones. Then once we finish squaring them, we sum them. Please, do you get that? We sum it. When we sum it, we get what? 1.757. Look at the between the group also. Let's look at the between groups very carefully. What is the between group formula? The between group formula says what? X I bar minus what? X bar squared. What is SI bar? SI bar, are they not the 6 we have here? Are they not the 6 we have here? 6 we have here, 5.99 here, 5.95 here, 5.95, 5.95, 7.3, and 7.53, 7.53, and 7.53. Are those not our SI bar?
Yes, sir.
If that is it, what is our overall mean, which is the S bar? Which one is our overall mean here? Is this not the value I circled here in red, which is 6.4? Please, have you seen that? That is 6.4, right? So what it means is that you subtract 6.4 from 6. You subtract 6.4 from 6. You subtract 6.4 from what? 6. So you see what you have here? You subtract 6.4 from that 6, 6.4 from that 6, 6.4 from that 6. So that you see that the first group, it will be negative 0.4, negative 0.4, negative 0.4. You see that they are the same. Then the next one will be that this next group, is that not it? The next group will be what? 6.44 minus 5.95. And they will all give you what? Minus 0.5, minus 0.5, minus 0.5, minus 0.5, minus 0.5, and minus 0.5. Then the last bit is that you subtract the 6.44 from the last group. Have you seen that? From the last group, because what you are doing simply over here is that you are subtracting each of the overall means, which is 6.44, from each of the xi bar, which are the group means. And once you have done that for each of them, you see here, let me circle those one also with let's say deep yellow. You see it here. Then we take their respective square. We take their respective square. And that way, you sum them up here. You see there, you sum them here. So now you see this sum here will just be the total of this one. So this is just the summation of this. This is just the summation of this. But you knew very well that when you want to do the F statistics, it's actually, so this one represent our what? ESS, right? And this represent our RSS. Is that not it? Now, if you have your RSS and the ESS, means that for you to get your MS for between is simply equals to your ESS divided by your degrees of freedom for the between. Is that not it? Then if you also want the MS for the E or for the residual one, is basically what for within, sorry, for within is basically what your RSS divided by your what DF what 2. And from this example that we have given, you notice that if these are the summation, what is the DF1? DF1 is what? N minus what? K. Is that not it? What is N in this case? Is it not 10? And how many categories do you have? Is it not 3? And that gives us 7. So the degrees of freedom for the 2 is also what? K minus 1. And we know K is 3, which is the 3 categories minus 1, which is 2. So it means that for you to now get the total divided by that, which we will now want to circle using this color. Do you get that? So you can see that these totals that we have here, we will not divide it by their respective degrees of freedom, right? Their respective degrees of freedom to be able to get the ESS. Now, it means that this one that we see over here, which is within 1, which is for the 2, you divide 1.757 by 2, and then you also divide, oh no, sorry, you divide the 1.757 by 7, and then you divide the 5.106 by 2, right? Divided by 2, and that would give you what? These dipping figures, the ones that I'm now circling with what? The violet color. Once I have these values, then I can now know that these are my what? MS. These values are now my MS. That's the mean squares. If you have your MS, all you have to now do is to now divide your MS for between by MS for within. That's all. And this is exactly what we are doing here. And we have what? 10. So once we have this 10, it becomes very, very, very what? Easy for you to now compare with the critical value that we look at from the table. The one we look at from the table when we take the chi-square statistics of the upper value of 5% is that we are going to get 4.74, which was in this case represented here. So you see that the values we're talking about, the 10.21575, is exactly what we had here, almost approximate as we are doing the computations. Any question from here? So these are some of the things that we are doing here. So basically, is the same thing that we are doing here, trying to show the differences. Of course, this is an output from a Minitab software that you can use for some of these analysis, right? Similar example also with the sum of square for the observations and then ESSs. So you can see the formulas that we are talking about. Remember, this one was given, but we are not going to necessarily be using this one. We will not be using this. But this is the ESS, the RSS, which is the within. Then this is for what? Between. Please, have you seen that? That's for between. So these are the things that we are going to familiarize ourselves with, and then to be able to calculate the F statistics for if we have the between groups and then within the groups. So a typical example also over here is what we have here. So the MG, of course, ignore some of these things. It's just a denotation that we always use to represent some of these things. In some books also it varies how they write the denotation. But the simple idea is that have it at the back of your mind that the ESS, or the sum of square for the group, the sum of square for the group is the same as the sum of square for the between, right? And the sum of square within within the group. Of course, let me go back to this one and add one more factor to it. So sum of square within the group, between the groups, is the same as the sum of square between, and it is the same as the sum of square for the explained, right? And then the sum of square for the error is the same as the residual sum of square, right? The residual sum of square. If you divide them by their respective degrees of freedom, that is when you get the mean square errors, and then the mean square between, and the mean square within. Then also when you divide the mean square between by the mean square within, then you get your F statistics. So these are the things that we are just saying over there. Now, the question that we ask about some of these things, remember when we are looking at the F statistics, is that we say that we should be careful because large values of F is against the H naught, right? So the question that we normally will ask is, so how big is our F statistics? Now, the how big is our F statistics is basically what we have been saying, that our mean square between divided by our mean square within, that is going to give us our what? Our F stat. It's relatively important more differences between groups than within group. So means that the variations is actually between the groups rather than it is occurring within the group itself, right? Rather than within the group itself. Which also means that for the values to be higher, means that between the groups are higher than within. That is why the values are so much. If the within the groups are higher than between the groups, then it might be simply as a result of more or less like sampling issues, right? So to get the p-value, we compare our, fi1 whatever distributions, and then the degrees of freedom for the numerator and the denominator, which are what we have done in those respects. So you see what we have here is basically to see our degrees of freedom between the degrees of freedom for the numerator and then for the denominator, to be able to compare it with a significant level to determine whether the test the critical values are smaller than the calculated or otherwise. Now, if we ignore the group for a moment and just compute the standard deviation of the entire data set, we can get something of this nature, right? That will give you our mean square for the totals, which is the mean square for the total is the summation of these two. When we sum the when we sum the e when we sum these ones, the SS for the treatment and the SS for the error, that will give us the total SS. So we also remember this formula, right, which we use in the computation of the within variations. Remember, it is also known as the SI minus Sij bar. This was for the between, within. Remember, this was for the within. Remember, it is the square or divided by Ni minus 1. Remember, just to remember that you have this to measure the sum of square. And remember, this sum of square is actually the variance that we are talking about. Is that not it? This is actually the variance. If we are taking the square root of this, then it changes to the standard deviation. Remember this, right? If you are taking the square root of it, it would have been the standard deviation. So this is just the variance. And the variance is what we are saying, the sum of square, right? For the within in this respect. So this means that we can actually compute our sum of square error from the standard deviation and the size of each of the group. And the size of each group is measured by the degrees of freedom, which is what we have indicated here. So it means that it is just basically the summation of what our errors, the deviations, n minus 1, right? Our deviations that we are trying to sum them for each sizes of the group based on the sizes of the groups. That is what we are doing in each of these cases. So remember, we have done something like this before, whereby we saying that then we are looking for each of the sizes, each of the groups and their sizes, and we sum them to the infinite, that is what is giving us this. So in fact, sometimes when it is in this form, it makes it much not appealing enough. That is why we look at it in the tabular form, in this form. You see that in this form, it's the same thing in this table that is being spoken about in these long terms like this. So if you are not understanding this one, you can stick with what we had done in the table, and then you should be fine to go, right? Should be fine to go with. So these are the things that I want you to take into consideration. So think about this one as some of the formulas that you might want to acquaint yourself with. The first one here is the sum of square for the total, right? That is the sum of square for the total. So this is the residual within. So this is within. Then this is for what? This is for between. So this is for total. And remember, if you add the within plus between, that should be the same thing. And remember, within is for the errors, and the between is for the model. In fact, depending on whichever software you are using, it will tell you, okay, the explain sum of square is the same as the model sum of square. The error sum of square is the same as the within sum of square, right? That is the errors, the deviations of the errors. So these are some of the things that you might like, or you are likely to be given so far as this thing is concerned. Now, R square you see over here gives us the percentage of the variations that is due to between groups variations. And this R square you see over here used to measure a lot of things. Now, how do we do it? It's just the group variation divided by the total one. So you see over here. So if I have calculated this once, if I have something like this, to get my R square is basically to divide this one, 34.75. So it will be 34.74 divided by 94. Then you multiply it by 100. That will give you the R square. So it's just trying to tell you the proportion of the between variations in the total variations. So if it were to be in the regression sense and then we are doing estimation, oftentimes you say that the proportion of the variations in your dependent variable or that is due to the explanatory variables that you have included in the model. In effect, what it's saying is that of all the total variations that is occurring of all the total variations that is being observed in your model, that proportion, which is 34.74 divided by 94 times 100, that proportion is as a result of the variations that exist between the groups, not those that existed within the group. It's as a result of the variations that existed between the groups. That is what it means. The variations that is as a result of the differences between the groups, not within the groups. So these are some of the things that I want to draw your attention to so far as this is concerned. So take note of some of these things. As part of some of the questions, you might just be asked that, okay, after you have calculated your S statistics, calculate the R square. So just take, and remember we have just calculated the ESS, right? ESS for the between, right? Sorry, the ESS, which is the same as the SS for the between. And then we also have calculated the SS for the within. If you have these two, you can add them together to get the total. So normally we say that total sum of square is equals to explain sum of square plus what? Residual sum of square. Do you get it? So the explain sum of square is the between, and then the RSS is the within. Do you get it? So if you're able to calculate this RSS and the ESS, if you sum them together, you can get the TSS. And if I now ask you what is the R square, just divide your ESS by your TSS. It's the same thing as what we have here, that SS group, which we already know that is the between group, sum of square, and then the SST is the same as total sum of square, or the sum of square total, which are the same thing that we have here. You see it here, which are the same thing we have here. So these are the things that the petty things that we'll be asking. There's also a difference here, of course, depending on the software that is used to run this. You can see a similar thing that is being displayed over here. And of course, the three groups that we're talking about, we have the three groups here, right? So you see there, the number of samples for each of them, and then their respective mean values and all that being displayed here nicely. So for multiple comparison point of view, once ANOVA indicates that the groups do not all have the same mean, we can compare them 2 by 2 using the 2 sample t-test. So if it is only 2 by 2, then we can compare this group by the other group and then be able to use the statistics to be able to determine by that. Other than that, it will be very difficult for us to be able to compare some of these things when they goes beyond 2 groups. That way we have to use the ANOVA and then to be able to do that. So I think these are some of the things that I wanted to do. I don't want to go through the details of it, looking at the Turkey's pairwise comparison, but I'll give you the slide of it. You read to get some more understanding, but these things that we are going to do and to examine you on that, we are not going to consider some of these things. And this is one of the things I always would want to test you about. Go and complete this. You know this. You don't know this, right? We have question marks here, 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 question marks here. You should be able to calculate that. You already know that MS is equals to what? SS divided by DF. Is that not it? So if I want SS here, if I want SS here, is it not simply for me to now multiply my DF by MS? So I'll just multiply it. I want my DF and I already have MS. I have MS and I have the SS. Then what I have to do is that I'll just divide my MS. My DF is basically equals to the SS divided by MS. That will give me the degrees of freedom. Do you get it? That will give me the degrees of freedom. Now, once I know my SS for the model and I know my SS for residual, once I add these two, I should also get this. Is that not it? Again, once I get this, I should be able to get this because I can even add these two, or what I will do is that my DF can be equals to what? My MS, no, my SS divided by my MS to be able to get this one. Once I get those values, my F statistics is simple, right? My F statistics is basically what? My MS, that is my MS for the model divided by my MS for the residual, and that will give you my FS, my FS, sum of square residual. Sorry, my F statistics. Now the R square to be able to do that is to do my model SS for the model, right? MS for the model divided by the SS for the total, and that will give times 100. That will give me my R square. But for this one, the mean square error, go and look for it. That one also, you can do some combinations over here to be able to get the MS square error. Let me see whether I have covered all the answers. And the good news is that the answers are already there. So if you go through very well, you should be able to see the answers and compare it with what you have. Let me see if I can. I have covered this one because, and then these two. We have what we call the adjusted R square and then the root mean square error. Because I did not treat that one with you, so I did not want to bother you much about going to find out more of those ones. But there are also more things to be able to do with respect to some of these ones because we even have adjusted R square and all of that. So these are some of the things that we are supposed to do. I know very well that if I want to go beyond right now and do regression, correlation and regression, you start talking. But let me hear your comments and then let's see what you do, whether you start the correlation and regression or not. Coach Rep. Coach Rep.
Please, the course rep is not in.
Hey,
Her
wow,
battery is still down.
the battery is still down. I know what I wanted to do last minute. Last days are dangerous. And I know that is just what I wanted to do. Let me take attendance. Abdul Laro. Hey, Salifu, man. Salifu. You hardly come to class, but today that I'm taking a random attendance. You are there. Douglas, Emisa, Ellen,
Sam, what's with you?
Obin, Emmanuel,
Dog, I'm here.
Chumesi.
Dog, I'm here.
Hey, somebody. Okay. Eric, Opoku, Asamoah,
Yes, sir, Doc, I'm here.
Eric, OSA.
I'm the
Then
same person, Doc.
you are the same person. Oh, okay. Then why
Eric
is your
Opita
this thing
Samoa.
coming? Oh,
Initially, I
okay.
was not hearing. Sometimes I don't hear, so I open my laptop too.
Faustina, Bedouin. What is that? What is that name? Is it Bedouin?
That please is body one.
Bedouin.
Body
Hey,
one.
bad one.
The German
International
name.
name.
The German
What
name.
does that
International name.
mean? Costa Fosu. Ibrahim. Sally.
I'm there,
Isaac.
sir.
Isaac Odru.
Dog, I'm here.
Faga. Toge.
Yes, sir.
Elisu. Whatever. The other name there, I don't know. It cannot even come. It's too long. Then Pius.
Dog, I'm around. Atambegu.
Atambiogo. Atambiego. You have names.
I'm around.
Then we also have what is that name? Mark.
Sashi.
Teshi. Which
So
one
I
is
thought
that
you are,
one?
yeah. Sashi.
Oh, okay.
It's my.
Japan
Say, are
name.
you an away?
So 1, 2, 3,
Say, are you an away? Doctor, are you an
4,
away?
5, 6, 7, 8, 9. 9 of you, 10, 11,
Dog,
12.
we are 11.
Exactly. So we are
Dog,
only
I
12
think I
here.
need my name. Dog, you didn't mention my
I'm
name.
sure the
I'm here.
person who is saying that you are 11 is not part, right?
Dog, you didn't mention my name.
Dog, one has left.
Douglas,
Hello, dog.
You said?
Yeah, you didn't mention my name. I'm
You went
here.
to
You didn't
sleep.
mention my name. Wait, I'm around.
Douglas,
Who?
You went to sleep. Good.
You didn't mention my name.
They say who?
Douglas, so he didn't respond. Dog mentioned your name. He did not respond.
You was sleeping.
Me, I'm in church, but
Oh, God fearing man.
You are in
dog,
church.
I'm in church. Yeah, I'm in
You are
church
not
listening to
in
you.
class. Yeah.
I'm in
So
listening
if
to
I'm
you.
in
I was
church
listening to
saying
you.
that I should also be teaching, can it be
No,
possible?
dog, I'm saying that I'm in church inside listening to you. When I go, that you would disturb me. So I'm in church.
So imagine that we are all in church, and how can you write this?
Dog,
And then
I'm not
if
saying that
later
I'm
on
in
you tell
church
me that
worshiping. Dog, please listen to
You
me.
are in
I said that
chapel.
I didn't. I mean, chapel doing the classes with you.
I have no problem. But what I'm trying to say is that whatever that you are, you have to make sure you are following and you are writing. About only about 2 or 3 people, maybe even that one, I still doubt whether they are even writing or not. But that's the question for the gods. Firstly, can we continue from here?
Hey.
The spirit is willing, but the soul is tired.
Hello, Doc.
Yes, I know you
Yes,
would
please.
speak the mind of your people. Can we continue?
Yes, please.
Uh-huh. So let's go through this one sharply.
So this one, should we
But
leave
I
it
will
to
see
the
if I
gospel?
can have some. If please, she has
If we
given
say
me the
we
green light,
should
so let me
continue,
flow. Okay.
we don't want your daughter to disturb us. If you say we should continue, make sure
Doc, please,
you are far away from your daughter.
Steve's father is in. Steve's father is in.
What is your problem? The person says
Steve's
we should
father is
continue, and
in,
what's your
Doc.
problem? So what is your problem if he says we should continue?
What she said, she's lying.
Don't worry.
Are you there?
Don't worry. I know that after the class, you will pounce on her that why did she say that you shouldn't break? You shouldn't break. I know that we will continue. Let's continue with this one. So correlation and regression analysis are also very, very important so far as statistics is concerned. Oftentimes, almost all the groups I have been teaching both online and then face-to-face, most of the times we don't touch on this topic. So you are fortunate that we are touching on it. And I also insist that at least let me give you some gist about it. In the next 30 minutes or so, we should be able to finish. If we did not finish, I know that we shouldn't be able to finish, and then I'll see if I can have a discussion with your rep so that you can give me some 2 hours within the week for me to go through some on some other aspects of the course with you. I think that would be very good enough. Now, correlation and regression are very, very critical so far as we want to understand association between events, whether events can influence other events and things like that, right? Now, to understand the meaning and the scope of a regression and then correlation is very, very key as one of the learning outcome that we want to measure so far as this is concerned. The correlation coefficient, which help us to know the strength of the correlation and coefficient and all that. The test to testing the significance of correlation coefficient, and then the meaning of regression, and then to do a simple linear regression, which is called the least square principles, and to also determine some coefficient of determination to be able, which is known as the R square. So the R square that you saw in the previous case, we are going to revisit it again, and then how it's helping us to know the extent to which a certain series of variables could explain a certain proportions of variations that exist in your dependent variable. What are the objectives of this course or this topic? Is basically for us to calculate and interpret the simple correlation between two events or two variables, to be able to determine whether the correlation is significant or not significant, and to calculate and interpret the simple linear regression equation for a set of data. Also, to understand the reason, the assumptions that are behind the regression analysis, and to determine whether a regression model is significant or not significant. Okay. Now, that is not all. We also would want to help you to understand or to recognize regression analysis uh, when we should use this and when it is needed, and what extra information is helping us to do beyond just testing hypothesis and all that, to recognize the potential problems that we can face when we are using regression analysis, and also to look at some or to recognize some nonlinear relationship between two or more variables. Now, we will start with this by looking at what scatter plot and regression correlation is. Have you heard of scatter plot before? Scatter plots is just a diagram that we use to depicts or shows the relationship between two variables. For example, if I have a Cartesian plane, x-axis and y-axis, and let's say, for example, as an individual, right, I may have a certain level of income, and I may be making a series. Sorry, something is coming up. My people, beg me. Let's take 5 minutes break. Let me deal with this situation and come back. Okay. That's unfortunate. We could have taken this break when we ended the analysis of variance, but it is coming at this time. So please and please let me see the time. 3:49. When it is exactly 3,
no, 2. It's 2:49.
you continue from there. I will still take attendance. That's not all. Like these are dangerous. So please.
Doc and the attendance. No. Hey.
What are we coming back?
Okay.
Please, have you closed?
They say
Okay.
go to break.
As doctor was saying,
Which
kata
I was to
plus
continue. You're
and
asking whether
correlation.
we are
Oh,
close.
please relax.
Eh?
I'm continuing. Oh, relax.
Did you what? Ibrahim.
What are
Please,
we
have
coming
you
back?
closed?
Is it? So you don't trust me? You people don't trust me like I can teach, eh?
Do you trust
Oh,
yourself? Do you
fine.
trust yourself? Do you
Oh,
trust
go.
Eric, don't let her be paid, I beg you.
Yes.
Firstly, I thought you are friendly. Firstly.
No, I'm asking whether we have closed.
Yeah, you have closed.
I read the one who said we should continue.
Look at this one.
Now we are going on break. What are we coming back?
Say 3 o'clock.
Okay.
Okay.
Ellen, are you there?
She's
Ellen.
asleep.
Ellen.
She's not feeling well. So she's asleep.
I will come to Pinay. I will come and visit you to see how best you are responding to the treatment.
Okay.
I think it will help.
Mr. Pius, relax. Sleep.
As a quadru, teach us how honeymoon is.
It's like some of you are
Mr. Rahman.
lectures.
No, our lecturer himself is aware that we don't understand. So that's why he said we are just following. So we are following.
Even you two, you don't understand.
You don't know that.
Me, I thought you are man. I thought I was the only one. This course, if God doesn't help us, it's going to be hectic.
The only one who is handling that. It's God who is
don't
handling
worry.
that.
Oh, don't worry. Everything is in control. Don't worry.
Which one is in control? I the one going to mark the scripts.
You have been on the phone for about 2 to 3 hours. You are saying you don't understand. Who should understand for you? I can't keep quiet and so far.
I'm saying that he himself said only two people, and he's not even sure whether they are right.
Devil is a liar.
Every blog will always have a cause that will bully us.
Yeah, that's how it is. But as Echo Mass 1 and 2, we got rid of them. No, that's the same way.
As Akufo-Addo will say, this we shall pass.
Hi, take control.
Yes, Abdul Rahman, your hand is up. Do you have any question?
The mic need drop in one country. And I make sure they will be. Hello.
Lodo.
My mic need drop in one country. Me home.
Lodo, who can say 3 o'clock in your journey tonight?
Hey, yeah, and it's 55. Okay, that's fine. So I hope all of us have joined. I know that some people are still not joined. Don't worry. This is where you get them. So with respect to what we were discussing, we said that for some reason, let's take for example, I have uh, a certain regular income every month, right? Or I have a certain monthly income. I'm not a monthly worker, right? But let's say, for example, I work monthly and I also spend monthly, right? So you would want to look at how whether my income has any correlation with the expenditure or the expenditure has any correlation with the income. Please, do you get it? So in that case, I may pick my 12 months information. So every month, how much do I spend? Every month, how much do I earn as salary or income? Then I can plot that, right? I can plot that over a certain range. That way, I can have, let's say, the income on my x-axis and then the other one on my y-axis, the expenditure on my y-axis, for example, and then begin to look at whether there's a relationship between them or not, right? So a typical example of doing the correlation matrix, sorry, I'm saying correlation matrix for that, is income, expenditure. So in that case, let's say I can have something like this. You can see a lot of dots, right? Do you get it? So it means, for example, if we take, for example, these dots, let's say if we take these dots, for example, what we are saying is that income level at that time was here and the expenditure level was here. If we take this dot, for example, you see that income level was here and then what? And expenditure was somewhere here. When we pick these dots here, you can see that income level was here, expenditure was here. So these are just scattered around based on the plots, right? So it helps us to see how these two variables are related or not related, right? Some might find out that the more your income is increasing, your expenditure is also increasing. That's therefore showing some form of trend in this form of thing like this. As you can see, the arrows kind of tilting towards a certain, you can draw probably a similar a line through it, something like that. That means that they are moving in the same direction. Or if they are something like this, they are in the opposite direction. If they are like this, means that changes in your expenditure does not influence your income. When it is like this, you say that changes in your income does not influence your expenditure in that respect. Now, correlation analysis is actually used to measure the strength of this association or the relationship, if you want to say linear relationship between these two variables. While the scatter plot will just show you the relationship in a certain XY plane, this one will show you the strength of that relationship. Only concerned with the strength of the relationship. Take note of that. The correlation is concerned with the strength of the relationship, but no casual what effects that are implied in that relationship. No casual inferences made, right? No casual what inferences are made. Now, so if you see over here, we have a certain scatter plot, right? So you see over here, if you draw X and then Y together, you notice, for example, some form of relationship like this. You can see the relationship seems to be like this. Is that not it? It seems to be like that. Then you can see another relationship with this second one. The relationship seems to be like this, negative. Then in another vein, in the curvilinear relationship, you see a relationship like this. And another way, you see a relationship like this. It's positive, although, but it is kind of like U-shaped, kind of upward, driving upward. These are non-linear or curvilinear relationship. That is these two. And these two also are linear relationship, whether they are positive or they are negative. So what you see over here is you have a certain strong relationship which are positive in nature, and you also have a strong relationship which are positive and negative in nature. If you look at this, you can see that this is a weak relationship because it does not show very compact, you know, compactly, like how they are very close together in trending in a specific direction. And this also, you see that they are not too compacted in a certain way that show a very clear direction. In this case, that shows a weak relationship. But if this one shows a very clear direction, then you can see it as a very strong relationship. But if you look at this one, you can see there is no kind of relationship because you don't know whether it is like this or you don't know whether they are like that, right? You don't know whether they are upward trending or downward trending, which makes it having no form of relationship, right? Again, if it is in this form, you can see that it is having no relationship because changes in income has no impact on, you know, impact on the dependent variable, right? In that case, X can change 1,000 different times, yet Y can still be in the same position as it is. Now, in this case, once you have seen the scatter plot, correlation would measure the strength of this relationship that we're talking about. As we said, no relationship. As we said, weak relationship. And as we said, strong relationship. The correlation matrix, the correlation coefficient will help us to determine the strength of this relationship, this linear relationship, or whether there is an association between these variables or not. Again, the simple correlation coefficient R is a measure of the strength of the linear relationship between the two variables based on the sample observation. So in effect, just like I've indicated it when we're looking at the the ANOVA, I said that the R square help us to determine whether the proportion of the variations in your dependent variable that really is measured by the independent variables in the model. So that coefficient of determination, which normally help us to look at the R, which is different from the R square, just give us, okay, if you said the relationship between two variables are, let's say, positive, how strong is that relationship? Yes, it might be positive, yet it might be a very weak relationship. It might be very weak relationship, but it might be negative relationship and things like that, right? So the correlation coefficient, which is the coefficient of determination, is helping you to be able to do that. What are the features of these simple correlation coefficients? One is that it is a unit free, it doesn't depend on any unit of measurement, right? And it always range between -1 and +1. -1 to me is that there is a perfect negative relationship between them. Positive one means there is a perfect positive relationship between them. If it is zero or very close to zero, we said there are no or no correlation between the two variables, right? So when they are to the extreme, it could be a perfect relationship that is negative or a perfect relationship that is positive. Now, the closer the value to -1 is, the stronger the negative linear relationship. Same thing applies to when it is positive. And as it's closer to zero, it means a weak relationship. So these are the conventions that we have. 5 conventions. When the R square, when the R is exactly -1, we say that it is having a perfect negative relationship with the variable. The two variables have negative perfect relationship. If it is positive, we also say that the two variables have a perfect positive relationship. Means that if one increased by 1%, the other must also increase by 1%. If it increased by 100%, the other 100%. So in such a case, when we are using such variables in a model, we often advise that then drop one because the other is providing us with the perfect information of the other one. Means that in the absence of the other, we can predict the other one that is omitted with the same degree of certainty. Then the second one, the next one is when we have R square being, as equals to -6 or plus or minus 6, 0.6, which is what a strong correlation. So this 0.6 should travel way to 0.8 to 0.9 something to show that it is a very strong correlation. When it is actually plus or minus 0.3, we can say that it is a weak relationship. And when it is actually 0, which is showing here, it may mean that there is no correlation between the variables. So how is that variable computed? It's computed using this formula. R squared is basically equals to the summation of x minus s bar times y minus y bar. And you know x minus s bar. S bar is the mean of x, and then s are the individual values. Same thing to y, individual values, and then their mean value. So those are the things that we do. Now, what you have here is just that the deviation multiplied, the x deviations multiplied by the y deviations, all divided by the square root of the sum of square deviations. The sum square deviations, the roots of the sum square deviations. So you see that each of these deviations you have written at the top here, you would have squared each of them. Their sum value, you now multiply them with the sum value for the y value also, right? That is one way of solving the R square. Another way of looking at the R square is to use multiply your n, that is the number of observation, by the summation of x, y. When you sum your x and the y, you multiply it by the n, then minus the sum of x times the sum of y. Then that is, and in fact, this one over here, for you to get this one, first of all, you have to multiply each s by y. Then when you finish, the summation you have over here will be xy, right? Then you multiply that by the number of samples, the observations before you subtract it from all the sum of S times all the sum of Y, right? Then at the bottom part over here too, you would have gotten the square of each of the S values, then you sum them, multiply by your N, number of observation, minus the sum of S squared, the sum of S which you would have done, you would have had over here, you would have squared it, and then you would have multiplied it with the rest of the items here, and that would help you to be able to get the R squared. Sorry, the R, which is the coefficient of correlation coefficient. Any question about that, or we proceed? Now, you see that these figures, in fact, they are not too different. All these things that you see over here, they are not much different. Any of them that you may want to take is up to you yourself. So let's say that these are the data that we have. You see that this is the data that we have. Let me see if I can use the. You see, that's the data we have. So we have the SY. So imagine, depending on whichever answer that we want to use, we may want to use any of them. So let's say this one. Let's say we want to use this one, the second one, right? The second one is also pretty easy for us to use. Means that we need this S by Y. So S by Y, 35 by 8 will give us 280. 49 by 9, 441. 27 by 7, 187. 33 by 6, 198. And then you get to the end part over here. So this figure would have given you summation of X, Y. I hope you get that. Then the next thing that you see is that you sum all your X and you sum also all your Y. So if you come here, if you sum all your X's and you sum all your Y's, they would have given, if you sum all the Y, would have been giving you 321. If you sum all the X's, would have given you 73, right?
Yes, sir.
Then the next thing that you need is that, so it means that the top part here, you are done with it. The next one you need is that you have to square each of the x's and sum it. So you come over here, x squared, and then you sum it, which we have here. So this is summation of what? S squared. Do you get that? And then you would have done same thing for y. Summation of y squared. You get that? Once you are done with this, you are virtually done with everything. Take note of this. That is the tricky aspect of the second formula. It's very funny sometimes to work with. It's very funny
Oh, come
sometimes
again.
to work with. I'm saying that what you have here, you must be very, very careful when working with this formula, especially the bottom one.
Yeah.
Why do I say that? You see this thing that you that are here. You see this. Let's see this. You see this thing is very different. This one is different from this. Y square, summation of y square, it means that you have to square each of the y before you sum it. But sum y square means that you have to sum them
On the Y.
before you square it. Do you get it? They are two different things.
Yes,
If you
sir.
square something before you sum it, it's different from you sum the thing before you square it. For example, let's have a simple thing here. Let's say 2, 3, 4. I have only these three values, right? Let me square them. Let me have this. Let me say summation of s squared and then summation of x squared. So let's say the first one, if I want to square them before, I want to square them before summing it, it will be 4 plus 9 will be 13, right? 13
Yes, sir.
plus 16. 13 plus 16.
29.
So means that this one would have been 29.
Mm.
That is the summation of s squared, right? But sum square s, it will be what? 2 plus 3 is what? 5. 5 plus 4 is what?
9.
5
9.
plus 4 is what? 9. So 9 times 9 square is what?
81.
81.
81. Have you seen the huge difference between them?
Yes, sir.
So I beg of you, even though the second formula look easier when computing or when you using that formula, be very, very careful when using it. Do you get it? Be very, very careful when using it because the sum y square is different from sum square y. Sum square of x is also different from sum sum s square is different from sum of s squared, right? So those are the petty things that you have to take note of. Other than that, you are done with virtually everything. These are the 4 things you need, 6 things you need. You need virtually you need how do you call it? You need the sum of y, sum of s, uh, sum of xy. Then you also need sum of
Some
y
of the
squared.
square.
Then you also need sum of x
That's
squared. Once you have that, anytime you need this sum of x squared, you can come and square this one. If you can come and square then 73. If you need sum of y squared, you can come and square this one. So that is basically what you have here. So you see it over here, right? So we just fish in and then plug in the values and then boom, you are able to get the r squared. So you can see this r squared being 0.8 something, which is greater than the 0.6, but it is also less than 1. So means that it's a strong positive correlation, right? Because it's even again positive. So it's a strong positive relationship, linear association between x and y. Please, I hope you get that. You may, if you go home, please, or if you are done, please and please, you can also try the second formula, the first formula here and see. Maybe to you that might be easier for you, right? I don't want to restrict any of you from using which one that you feel so comfortable with. Okay. All right. This is the second aspect or the correlate. Excel way. You can do correlation analysis in Excel. Let's say, for example, you have this. Let me see if I can have my Excel open for me to demonstrate something like that. Let me see if I can have. Let me see. So let's say variable x, y, and variable x. Oh, look at me. I'm doing it to myself, eh? And you will not tell me that you cannot see my Excel book.
Uh,
So I'm just typing some random numbers, right? So you see over here, I have values here. Let me see and use this. What should I do here right now? In fact, if it were to be external software, it would have make it even easier. So you see, I have ages, right? Let's say this variable y is called what? Let's say income, right? No, expenditure, and my x is what? Income. These are my income and the expenditure. All I have to do to this is to go to my, oh, I supposed to have oh, do I have that installed? My data analysis tool pack. Let me see if I have this installed here. Oh, I don't have it open. So I'm opening it. Moving average. Okay, so you can see over here correlation, right? Have you seen the correlation? Oh, have you seen
that's
it?
why.
Okay, so let's look at it from this angle. Let me use a full screen projection. Sometimes I don't like that because of how this thing is, but I think that's the only best way to display that. Can you see my screen? You can see my Excel, right?
Yes.
Yes, sir.
Yeah.
Yes, sir.
So you see that what I have done is to highlight my data points, right? And then I go to data and I click on data analysis at the far end over here. Once I click there, what do you see here? I see correlation. I click there and I say, okay. Now they ask me to input the range, the columns, right? The columns. I can now select the two columns, the data itself, and I said, where do you want the output to be? I want the output in the new sheet or in the output range. All I have to do is to click the output range and click here, and that's okay. I say, okay. What have you seen? You see that it has simply given me a correlation matrix, right? A correlation,
Yes.
simple. You say, right? You see, this thing, I wanted to prove to, I want us to prove whether that answer, the one that we just use the formula to do, right? I wanted to see whether we can get it when we go through the process. Now, from the slide, you notice that for us to calculate the R, we need something like this. So I just need S times Y. Is that not it? So I need X, Y here. xy here. I need also over here, I need y squared, y raised to the power 2. And I want also over here s raised to the power 2. I know it's almost time, but please permit me to do this one quick, okay? Can you please mute your mic and let me finish this very quickly so that we close? So over here, you just do this times this times that, right? Adana. Then I just do auto fill for it. Over here, all I do is that equals to raised to the power 2. Then I just do what? I just auto fill it. Over here too, I just do what? X raised to the power 2. That is the square of it. I do what? I do this. Now, what are the formulas saying? The formula is saying that over here, let me do summation. Summation.
Summation of y.
So the sums over here, sum, I wanted to have the sum of this.
Yeah, okay, I hear you again.
Doc, can't hear you.
Seems he's picking the formula to place on it.
My
His
mic has
laptop
been muted.
is on top.
My prince rightly said is that I'm picking the formula to keep it here so that we can easily see it. So you see the formula is saying what? What we have to do is that what is n? N is the number of observations, right? How many are they? They are only 4. Is that not it? They are only 4. So it means
Yes, sir.
that equals to, let me create a bigger bracket, right? The first bracket is saying that n, which is 4, times what? Into brackets. What is the sum of x and y? The sum of x, y is 6,000. So let me click here, right? Then let me close the brackets, minus into bracket. Summation of x times summation of what? Y. Is that not it? Then let me close the bracket. That means I'm done with the numerator.
So,
Then let me divide it by, let me now write the denominator also. The denominator starts with what? The square root. The square
4.
square root. So this is the square root of
4.
something. So let me now open the bracket again. N is 4. Is that not it? I type 4 into brackets. What is s squared? Summation of s squared, which is this.
5,500.
Exactly. Bracket close, minus into brackets. What is the sum of s? We have to square that. Sum of s raised to the power 2. Then we close the bracket. Right? All these things times. So let me close this times, because this green covers this. This one also cover this. So this one will cover the whole of this. So it's actually the whole of this that is being multiplying the whole thing. So that's fine. So let's open another bracket now. 4 again, multiply by
Y
what
raised
is
to the
y?
power
What is y
8,000.
raised to the power?
8,406.
406.
Exactly. Okay, right. Minus
Summation Y squared.
summation y squared. So y raised to the power 2. Is that not it?
Yes.
So once you hit, there's some error with the formula, but it has auto-correct it. Look at the figure plus what we had there. Is it not the same thing as this?
Yeah, the same thing.
0.883.
So it simply means that anytime, let me see whether I can indicate these symbols. Yes, this is what I'm referring to here. Yes. So this is what we are talking about here. So you can easily, or you can clearly see that the formula that we're talking about is not too different or difficult. Do you get it? The moment you do it in the tabular form and you quote this your formula, you see that it's the same as what we have over here. The same as, and the good news about some of these things, you can even increase the, how do you call it, the decimal places. You may want to increase the decimal place to whatever. Over here too, you may want to increase the decimal places. Sorry.
This is for Excel.
Doc, this one, I think
You see that?
there should be more of this in the quiz that we use computer to do.
In fact, you can get this in the exams, but maybe by the time you figure out how you can use the computer, then the time is over for you to submit.
This one is
But
equal
Doc, the way
to
that you have done it, me, I've captured it long time, class.
The thing is, if you want you to do it like that, I have ever written exams with Excel like that before. I know what I did, and I don't want you to do the same thing. You know, sometimes students want to be smart. What they would do is that they would have developed this formula down. For example, if I now give you a different set of x values, let's say x plus, let's say x, let's say these are even huge figures, right? Let's say they are only, you know, these figure. Then I'm giving you these y values. Let's say this. Let's say we have this, and I tell you that these are the y, or y, and then this is x. Do you know what the student will do? He will just copy this. The moment he copy this and place it here, that's all. The formula will automatically pick everything. You see that? It will automatically pick this. And then he will also go here and resolve this one. If he resolve this one, all he has to do is to go to insert, sorry, data, G pack, say equals to, select the range as it is before, which is select this range and say the output range should be in here and say okay. Is that not the same figure here? This figure.
The same thing.
So you see that he will not, that means within the just 30 seconds, I would have solved the whole question, and all I'm doing is to copy and put it inside my book. For no work done. This one, when I mark it, who should I give the mark to? I'll give it to the computer.
You give it to technology. Yeah.
You see. So these are some of the beauty aspect of some of these things that we have done throughout the whole semester is that machines can do these things with ease. And because unfortunately we don't have those extra time to be able to practice some of these things, I'm unable to demonstrate them using the softwares to even a simple Excel. Oftentimes I say it, Excel, what Excel can do, excuse me, for this part of the world, we even use 20, less than 20% of Excel. What Excel can do. You can use Excel to even create receipts, right? Receipts and all that. These are just automated systems. Once I automate the system, all I have to do is, and you see what I have done now. I can always go back and go to my formula and show wherever there is a formula on this sheet. Show formula. You see that the whole sheet has turned to formula. Everything you see over here. So if I'm marking the scripts and the student says he has not used formula, I will just go to that place and activate, and you can see every place there is a formula. You see the formula showing. You see these ones. So it means that you have linked the sheets down already. You don't need to now be inputting the formulas again. The formulas itself would have given, show you everything that you are doing behind the closed door. The only thing you are changing is only here. Once you change here, my brother, my sister, everything is changed. Even this one that you have calculated as, the correlation matrix over here, you can also do that using an automated system. And by the way, if you were to do the regression analysis, I'm just trying to conclude. I don't want to go to the slides and further this thing. If you want to do regression analysis to, let's say these are the two variables you want to do regression analysis to on, you can just go to data over there, go to analysis, data analysis, select regression. What is it? The ANOVA that we talk about, you can do all of these things here. You see regression here. You select that, you say, okay. They say input the y-axis, y range is here. And then x range, input that. Then show the labels. Input labels, another confidence level. You want to use 95%. You may want to use that, which is equivalent to alpha level of 5%, right? The output range, we want to specify where the output should be. So I just click output and I click here. Then I want the residual sum of square. I want the standardized residual. I want also the residual plot. I want the line fit plot, normal probability plot. I want that one also. So I say, okay. You see what has just happened? This is the regression line. You see the sum of square residual that we are calculating using the ANOVA. You see the ANOVA side. This is the ANOVA values. This is the ANOVA. So you see the degrees of freedom for this. And you see the significant level, right? You see your MS values. So it also means that if I had selected just a few values, these figures would just be small values here. And then the result itself is what we have here. And you see p-value is very less than, and your test statistics is smaller. So you can see this test is not significant. And you see the correlation matrix for this has already shows that there's a negative correlation of what? 0.36 something. So if you come here, you see the impact of variable x. You notice that variable x is having a negative relationship with what? Y. You see it's the negative here. So regression analysis also confirms that, right? Now, the R square, which is 13%, you can see it over here, which means that if I say equals to here, my regression sum of square, that's the sum of square, divided by the total sum of square here. That should give me, oh, you see that it's not showing the answer. Somebody should tell me why. Why is the answer not showing? It means something. No, the answer is showing, but because of something I have done. So I went to formulas and then I show only formulas. I didn't show the answers. So if I say formulas right now, it will show. You see it here. So you see that is this figure not the same as this? You see it? Let me push it to the top so that you see it very well. Is this not the same as this? Now the F statistics also, this F statistics you see over here, let me calculate it also equals to the regression sum of square divided by residual one. Is it not the same thing here? This and this, is that not the same thing? So all these things, you can always validate them, okay? You can always and always validate them. So take note of some of these things, and then next time you should be able to compute them yourself. So these are the petty things that I want us to avert our minds to. So of course, if we give you a simple correlation matrix, you should be able to do it. But unfortunately, we are unable to use it for a hypothesis testing to be able to test whether R is statistically significant or not. We would have done that and then start the introduction to linear regression and all that you can see here. So when I give you the slides, please and please, you can play with them, go around it, and then work out with it, okay? All right, any question? Then we end it over here. At least we have gone 18 minutes beyond the time. So tell me what the questions are, and then let me see. I'll surely share some these things with you, and I'll surely share some series of questions with you for you to play with them, okay?
Okay.
But please and please also make sure that you are able to go through the ones in the textbook. Okay? Go through the ones in the textbook. I beg of you. Just go through. I know that it's not easy being there.
This
If you're
time
in
round,
the
you're
house
going to
and
solve
you are
every
learning,
question.
you said?
This time round, you're going to stick to your device to solve every, self-question assessment. Whatever.
So, any question? Coach Rep, you want us to talk backstage?
Course rep is not serious. That's
It's not with
Hello,
you.
sir.
Okay. Let inform her to call me so that we see whether we can be able to plan for some 1 hour or 2 hours to go through some questions.
Hello, sir.
All right, Doc.
Yeah.
Hello, sir.
Yes.
Sir, please, Mr. Menu.
Yes, please. I'm
Hello, sir.
listening.
Well, I beg you, the multiple choice items. If you can reduce it to 4 so that you end at D. The E sometimes a Boolean. One will struggle to get the answers. Sometimes it becomes something else. So we beg you, if you can reduce them to D, so that we may have A, B, C, D instead of A, B, C.
What about if we should even make it A and B?
F.
Or we should make it A and B, true or false?
A to K.
It's not false.
Dog,
we should
that
make
true
it
or
true or
false
false.
card, they kill me. They kill me.
That
true or false.
The true or false.
No,
The true or false. The funny aspect is that if it is not this one, it is this one.
Yes. Can you score them?
Dog, that
Now,
one
if
you will
it is
get
not
zero.
this one, it is this one.
We surely get zero. That one.
Yes, sure.
We use probability to solve it.
You use the probability that this one will be the answer and not that one. Then you use
Some guesses are dangerous. Some guesses are dangerous, my dear.
Right now that for Steve and then Ellen is not in the class, all of a sudden,
Yeah,
for
in.
Steve and Ellen is
Doc,
not
we
talking.
don't know them. Doc, we don't know
Invisible
them.
spirit.
Doc.
Especially Ellen. Ellen says she's sick. Ellen, are you not sick again?
She's lying. She's lying.
Ellen.
Isaac Odro, are you there? Do you know where about this? Please.
Ellen, Ellen, I want to hear your voice.
Sir, she is sick.
No, I want to hear her voice. Nobody should talk for her.
Doc, she's lying.
Odro, be careful.
Ellen, can I hear your voice?
Doc, please, I'm around. Eric and Fosti are praying for me, so I'm feeling better now.
Yes, I did fasting for her. I just break my fast.
Indeed, I pray for
just
you.
wait. Let me ask this question. Can I get your mobile money number?
Yeah.
Yes. I'll forward it to you, sir. You see that? You see, human being. I'm taking my attendance, Salifu. No, let me start from here. No, Mark. Mark is not there.
Mark is here, 24/7.
Salifu is there.
Sir, present sir.
Douglas is there.
I'm here.
Ellen is not there. Chumesi is
Ellen
there.
is sick.
Please, I'm here with my mom.
She's sick.
Ellen has taken it for tablet.
You see,
Tablet.
it's your Momo number. Eric, Eric Asamoah is the same as the Eric OSA.
Yes, please.
Then for Stina Abaduon.
Yes, sir. I'm here.
FF Foster Posu.
Yes, sir, he's here.
Then Ibrahim Salih.
I'm there.
Isaac Odro.
I'm trying to do that Lagrange.
Yes, sir, I'm here.
Then Pag.
Yes, Doc, I'm here.
Then Pius. I think Pius.
Doc, I'm around.
So these are the regular members, right? These are the only faces I know that have attended my class today also. Those that I have identified before then, you take note of them accordingly and note that they have not been coming to class. So I would have a conversation with your rep, and if it happens that we are unable to meet again, wish you well in your exams. But if you meet again, probably you will thank things before then. All right. So let's discuss rep behind stage and then have some arrangements. Okay.
Hello, Doc.
Hello, Doc. Somebody say, is on and off.
Okay. Simon.
Yo, Ade.
Dog.
Simon.
What are you?
Simon, when right?
Yes, sir. Yes, sir. Yes, sir.
Simon.
Hey.
Who's that?
Who's that?
I'm not Manu.
Please.
Manu
or Manu?
There is Manu.
Manu.
Yes, sir.
All right, Manu. So if there's nothing, I'll log out. Okay.
Okay, sir.
Dog, this one is well understood, man. So if more questions come from you.
Oh, Jack, we been on linear, we been one with Baba quiz, and can you probably be at all?
Dog.
Doko coming.
We just move at home. Eco304SD.
The whole house.
I have to say,
Eco304SD. Should be that.
Mr. Eliasu.
Wow, how be a Fabran.
Mr. Eliasu.
Correction the Econti.
Eliasu.
It won't be that.
Hello.
Your woman said we do have a class this afternoon.
Yes, 5.
Oh, we are tired though.
Hey.
It's not
Yeah,
fair.
bro.
No,
What's that?
You are retired.
tomorrow is the presentation.
In fact,
Which presentation?
When it will be a last meeting, so we need to meet another.
She should send us. She should send us
I'm
sample
saying.
questions, not lectures.
I can say abre.
Public sector.
Hey.
What's that? Can we try that?
Or she can take some minutes to present a work, then later on we present ours too.
Our work, we are presenting tomorrow. So we are meeting to film the.
Yeah, I know, but I'm saying you can take part of the time for teaching them, give us the minutes.
Well, I
Isaac Godreau.
What are you doing now?
Isaac Godreau.
We are close.
Hello.
Elias, can you catch it on? Are you going for the class?
Come again. Are we doing what?
Mr. Mark, please we are down for the class.
Okay.
If you have, I will let you know. So we have to be monitoring the platform. Hey, this Anova, I don't understand the Anova. Who understand it? Because see.
Which one? Anova.
Anova.
Anova. Easy.
You were following to say, okay. You guys were following it now. I say it's not easy. Why it's not easy again? I will take me through. Ellen.
Ellen. Don't worry.
Hello, sir.
Yes, the lady asked us a question. Can you remember the question she gave us the other day?
Please, please let me check. I'll get back to you. It seems I wrote it somewhere.
Okay, so you can send it to me so that we'll make some research on it.
All right.
Is that Elias?
Yeah.
We say all the Anova.
Yeah, no, I mean, take me through. Or what do you say?
No problem. We go meet. We go through and see. We go meet.
Tomorrow I will call you.
We go meet. No worry.
I will call me, take me through.
Hey, it's not easy. We are doing things so.
No, it's smart.
Because you are doing things fine.
No, it's smart thing they do. Let's just pray that we'll finish these things and also rest more. Maybe.
And this last one, yeah, it was easy to understand the correlation.
I think this one and then the what is it called? The chi-square is better.
That one is true. The hypothesis and the other one, the estimation, the chow.
Yeah.
That one is chow. Well, the last time today, the network disturbance found. The one that we did last
Yeah,
week.
in the morning.
The sky, the sky test square. No? The test square. No?
Uh,
I said the
that
last time
one,
the network wasn't good, so
yeah. But
the
even that
network
one,
wasn't good. Yeah.
that is better than the other ones. Yeah.
I didn't get the distance. The observation. I have to calculate the observation distance values.
Calculate the critical values.
The observation values.
That one, maybe. Don't worry. When we meet, you teach me this. I could teach you that one.
Okay.
Very simple.
So
maybe let's hope that tomorrow we can be able to have some time. Then see where we can do something. All right. I'm going to pay so later.
Okay.